We're building a 1,000-mile-an-hour car and sharing that story with a global audience. It's part supersonic jet fighter, part next-generation space rocket. Our mission is not just to go fast. It's about creating an engineering adventure to inspire a generation about the magic of science and technology and bring it to life in the most exciting way possible.
Well, welcome to all of you watching our live stream. You join us, myself, Mark Werrell, and Jenny Gow, here at Cornwall Airport, Newquay, in the southwestern corner of the United Kingdom, where in about 15 minutes' time, the EJ200 jet engine on board Bloodhound SSC will burst into life, and it will taxi onto the runway and make 2 high-speed runs. It's 200-mile-per-hour public debut. Jenny, the tension is starting to build, and we're going to make a little bit of history in not too much more time.
Yeah, absolutely, and people are really excited about this event. It happens to be half-term here in the UK, so loads of kids, loads of families have come down to Cornwall. It's a beautiful part of the world. To see exactly what's going to happen here, and you can sense outside that people are really curious, they're really excited, there's a sense of anticipation, and you're looking at this being the very first shakedown, so the first chance they've got to see when this vehicle's actually running at any sort of speed. Are there any problems? Is there anything technically that isn't quite working? It's all put together for the first time, and that's what people are really excited about, isn't it? Because for someone that's been involved in this for a while, this is the first chance they've had to see all of the bits put together, and Andy, the pilot, the driver, will go out there and see what it's like.
Well, I mean, how could you not get excited when something is dark blue and orange, and it's 13 metres long, it's got a flame coming out of the back, and it makes lots of noise? What's not to get excited about?
I agree with you, absolutely. I mean, anything for me with an engine in it is good, whether it be a lawnmower or, you know, anything upwards, Formula One cars, rally cars. But if you look at this vehicle, you automatically know it's something very different. It's something groundbreaking. And, you know, we've been here all morning looking around, getting a taste of what's happening out there. And it's not just, as you've said numerous times, about a car going very fast, is it?
No, absolutely. No, as we've alluded to when we've been discussing it over the course of this morning, the main goal of the car is not purely about speed. The main goal of the car is to inspire the next generation of young people that science, technology, engineering and mathematics, or what we call STEM subjects, are important and can provide some fantastic careers to people. And we talk about engineering, but engineering is a generic term. You know, you've got automotive engineering, you've got structural engineering, you've got aerospace engineering, you've got genetic engineering. Engineering is a term that we use, and I don't think children truly understand that whatever we do, you know, the stool I'm sitting on now was created and designed by an engineer. Sound engineers are all around us as we're in the studio. So it's, to say engineering, you know, there's so many different aspects of it.
Yeah, it's a very global term,
it is.
Isn't it? Oh, and talking about global, if you want to get in touch with us, maybe let us know where you are. If you're watching the live stream, then please use the hashtag BloodhoundIsGo. So maybe send us a picture of where you are. If you're here today at Newquay and you've managed to find a perfect spot, then use that hashtag BloodhoundIsGo and let us know how you're doing, what you're doing, and if you're enjoying it.
Well, over my right shoulder 5 minutes ago, somebody was doing a selfie with Andy. There is no better selfie today, isn't there? With Andy Green, the fastest man on the earth, 763 miles per hour 20 years ago in this car's predecessor. And I was there, I was at Farnborough when Thrust 2 did its last ever runs, or sorry, Thrust SSC did its last ever runs at Farnborough in 1997. And I recall, you know, as we're going to see out there later on, that car taxied down the runway in runway specification, so not necessarily all the bodywork was cloaked, because the wheels, when the car runs tyres, are slightly bigger than the solid wheels that were running in the desert, so they can't put all the bodywork on. And you heard those engines start to spool up, and then the car goes down the runway and you see that enormous E-flux, as it's known, the jet engine, the afterburner come on as the car hits full reheat. And 20 years later, it's putting hairs up on the back of my neck. It's fantastic.
I love the fact that wherever you go today, it's like talking to kids just the day before Christmas. There is this sense that something phenomenal is about to happen. And the process of what people can expect over the next few minutes, I mean, at the moment we can see the live images of Bloodhound. It's parked up just outside our studio, actually, and it will move into position shortly.
A few years ago, there was a retired American professor came to the UK, and he came to its Bristol base. He wanted to learn a little bit about the Bloodhound project, and well, he taught engineering. He knew a little bit about aircraft and rocket systems, and he was impressed by what he saw. He also endorsed the project. You know, he endorsed the idea behind the project, that thing that would, you know, push the imagination, push the boundaries, captivate the imagination, and hopefully inspire young children, which is what this project is very much about. And one of the team down there suggested that, you know, this is potentially an Apollo moment for the next generation. The American thought about it and agreed. He agreed and thought, yeah, Bloodhound has the same capacity to captivate and amaze the audience and get the world looking in one single direction. And that legacy that it could create, as we've just heard from Sylvia, could hang on for many years indeed. Now, when the Americans said that, that meant an enormous amount to the team that were there, because this guy was not only a professor, he was not only an engineer, but he'd also been a test pilot. He'd also been an astronaut. He'd also walked on the moon. And that man was Neil Armstrong. He was a fan of the Bloodhound project, and we've got many of those here with us today. You look around and there are many people that have been engaged with this project for so long, around the globe as well. And this is an engineering adventure that's being followed in just about every country around the world. So we have got enormous amounts of knowledge, of experience, of enthusiasm here today.
Absolutely.
So I think what we can do is perhaps just maybe have a look at the mighty EJ200 jet engine that powers Bloodhound SSC, and will be going to work as it heads down the runway in a few moments' time.
A pencil-thin rocket car without any air intakes like the Blue Flame would seem to be the optimal design for a land speed record car. So why do both thrust cars and Bloodhound SSC have jet engines? Jet engines are a tried and tested technology. They're safe, efficient, and amazingly reliable, giving large amounts of power almost at the push of a button. Older engines are not too hard to find, but Bloodhound has been lucky enough to obtain a Rolls-Royce EJ200 as used in the Typhoon. Small, light, and hugely powerful, it's one of the most advanced engines available today.
But we're clear this side now, so if we go down slowly.
Because Bloodhound is effectively a prototype, the development will involve making many runs of gradually increasing speeds, with the team comparing the data from the car with their earlier computer predictions. A jet engine is perfect for this, and with more than 20,000 pounds of thrust, the EJ200 can get the car to over 600 miles per hour. However, for the first test, the car is firmly tethered to the ground. The big questions are, will it work? And can we get reheat and a static test where no air is being forced into the small intake?
belong here, now go.
Well, the team is now getting Bloodhound SSC ready to start. So we'll ask you that you all follow the Bloodhound team, follow their instructions, and they will show you to the viewing area here at Cornwall Airport, Newquay, where you will get just one of the very best views of the cars running. You can see that one of the last planes is now just coming in here at Cornwall as well, and this is the last flight. It's come in from the Scilly Isles, the Skybus landing at Cornwall Airport, and that's the last flight that we are now expecting to come in, and very shortly we'll see the airport will hand over the airports to us, Jenny.
Yes, we were hearing just earlier that they've actually closed this, an international airport. They've closed it for an hour and a half so that they can make sure that the run is done safely. And they've got to wait until the very last passenger is in the airport before they can start manoeuvring things around. Otherwise, they were worried, health and safety reasons, that someone might fall down the jet. And I expect if you see the Bloodhound on the move, it might take your breath away slightly.
We've got another guest that's come to join us for this very important part of the day, and he's a very important man as well, because Bloodhound Chief Engineer Mark Chapman has come to join us. So welcome along, Mark.
Good afternoon.
We really appreciate you giving up your time for what is, the pivotal part of the day. First, of all, the car is right outside the studio at the moment. Your team, your engineering team, have been around it. They'll now be starting to work on certain aspects, will they, in preparation for the run. So just tell us, what are they doing in that area at the moment, straight outside of the studio?
So basically what you see them doing at the moment, this is like the pre-start check. So this is them walking around the car, and this is checking everything's where it should be. So we revealed the car this morning. We then, a bit more than just polishing and check the kit, check the tyres and check the fluids. We've now brought it round here, and this is now getting it ready. And the next time we wheel it out it's now going to be taken around to the start area. We're then going to get the air start going and then get Andy in the car and all those good things. So it's those final preparations. So it's checking that everything is as we left it as it left the house. So from the hardened aircraft shelter to here, that nothing's gone wrong, everything's happy, we've got no damage, we've got no foreign objects that we're worried about, and it's really clean and good to go to start the engine.
Now, I think you're going to have to decode a few things for people who maybe are watching around the world and are new to this. When it left the house, did you have it at home this morning in bed with you?
Yeah, so we had it in a house. We're very lucky here at Newquay, so we've got a hardened aircraft shelter. So when the Royal Air Force were here as a base, they're these very large, you'll see them around the airfield, these very large concrete hangars. We've been based in there now for the last 3-4 weeks, and we've been doing our low-speed testing here, and actually just checking the engine and things like that. Actually, if we go back to 2012, we were here doing the rocket testing, and where we are now is actually quite, for a lot of the team, is quite emotional because there was a blast wall in there, and we fired the hybrid rocket here in 2012, and it's got a huge amount of heritage with us being down here at Newquay.
Okay, so the house was that sort of base.
The base, the hardened aircraft shelter.
There we go. That's good. Thank you.
And I think we can see some pictures of it now from earlier on, for those of you who just joined us on the live web stream around the world. The car was revealed out of the hardened aircraft shelter this morning before the sun had even come over the horizon at Newquay, so it's now UK time, just going up to 1:45, and this was around about what time? This was about 7 o'clock, 7:30 this morning, Mark, was it?
It's about 7 o'clock this morning. I mean, it was fantastic. You know, it felt a bit like something out of 2001: A Space Odyssey, or it had all the lights out there. Came out. Somebody said about having a smoke machine, but as we came out, the mist and the fog was doing it itself naturally. So the Cornish weather was helping us as it came out. But it looks stunning.
It's fair to say that the weather there, as we see it at 7 o'clock this morning, it was rather misty, and now this must be almost ideal conditions for you.
This is ideal because the way the weather is now, there's a few patches of blue sky. And but actually having a slightly cloudy background, you will really get an impression of that engine. When we start the EJ200 and it starts to pull away, you will see that engine go to reheat, and it will be like somebody's brought the sun onto the runway.
That's Andy Green that you're seeing now. He's the man that will be behind the so-called steering wheel, I suppose. Just explain a little bit, if you can, about why him, what his responsibilities are today.
You know, so Andy Green, and it is a steering wheel. It's very much, this is a car, and it's what's fantastic about this project is it's something that people can relate to. It's 4 wheels, it's steering wheel, here's a throttle pedal and a brake pedal. He's been part of the project since the inception, so he is already the world's fastest man. He's driven a car at 763 miles an hour. There is nobody better. There is nobody that you could think of that is calm enough and has that kind of measured. This isn't about going quick. This is all about it's understanding risk and managing safety, and he's been part of the design team for the whole length of the project. Though this is a car that's designed around Andy and his skills and his capability, and he is the perfect person to be doing this job.
How important do you think it has been for the team and the core engineering team to have continuity of individuals from the outset of this project? When you think of, you've mentioned Andy, but we've also, of course, got Ron Ayres, and you've been there since the very early stages, so that must be enormously important.
This is a continuation. This was, the inception of this was from Thrust SSC. So the team that broke the sound barrier, 763, they've just had their anniversary. Having that group of people, so Richard Noble, Ron Ayres, Martin Davidson, Andy Green, all those people involved with the project. This is the finest team you could put together to actually start off doing a supersonic car. And actually the team that we have with us here today, and the past members that are here today, there's this fantastic enthusiasm, this passion for breaking the land speed record, and you couldn't hope to work with a finer group of people.
And when it comes to that group, just tell us a little bit about the choreography of where people are now, who you're talking to, because I know you've got a radio on your lap, and we'll be waiting for communication of what's happening around the base here at Newquay.
So yes, I have a radio on my lap. Hopefully I'm not going to be asked to do anything, because that'll be quite interesting. But no, so we've got a start team and a receive team, an engineering team. So there is a choreography to how this car works. It's we pushed out, and then they'll put it into a start position. We then have an air start cart. So this car doesn't have a starter motor. So we use another gas turbine. So we use a small jet engine to start the big jet engine. And actually, when it starts up, that's the loudest thing you'll hear. So you'll hear this roar, and that will be the air start cart. That blows hot air across basically a turbocharger. So there is like a turbo within the car. That spins around, that connects to a gearbox, then from that gearbox is a shaft that drives into the main jet engine. And that will bring that up to a speed. When it gets to a certain speed, you'll then be able to start the igniters and the jet will start working. It will self-sustain, we'll disconnect the air start cart, and the car's ready to roll.
So we can start to see the pictures. The car is starting to roll, but it's starting to roll under pure manpower as they begin to wheel the car out. And it's fair to say that Andy will not be in that driving position when he's heading down the runway later on. He's got a cockpit which will keep him safe and sound and give him all of the comms that he needs and all of the information that he needs whilst he's performing these high-speed runs.
So one of the things about that cockpit, that is very much designed by Andy. So everything is where he'd like it to be. So everyone thinks driving a straight line, how hard can that be? Actually, if you look at the footage on the internet from YouTube, from what was Thrust SSC was like, there is an awful lot going on. I mean, this car accelerates like no other car you've ever seen. There is a lot to do, slight side winds and all those sort of things that need to be corrected. What is unique about Andy is that ability to look at all that information, to be able to calculate what's going on, whether that be measuring brake pressures or engine thrusts, fuel flows, and doing that all in a very short space of time. So we're expecting to go 0 to 200 in something around 9 seconds, and that isn't a very long time at all.
Mark, can you tell me what Andy will be feeling and what he'll go through just to get to that 8 seconds and then on the other side?
So Andy will taxi around the runway. Actually, I'm supposed to call it driving, but he drives around the runway, and we'll go around the taxiways and get to the holding point just before the main runway. We're very lucky with Newquay here. They've actually, as you were saying earlier, that they've closed the airport to air traffic, and we have the use of this runway for the next hour and a half. Now, so Andy will hold at the start of the runway. He'll do his own internal checks. So he'll go through all the systems and all the things that he wants to know that he's happy and comfortable with. He'll then call to the tower to get clearance to run down the runway. He's a car, so he's got a throttle pedal. He will put his foot down on that throttle pedal. The engine will start to come up, and as we start to move forward, it'll then start to move into more and more power settings. This is a fly-by-wire engine, so there isn't a lever pulling on a load of fuel, so it will accelerate gently, and then more and more power will come in, and then the reheat will come on board. And then he'll be on reheat for maybe 2 to 3 seconds.
Can you explain what reheat means for people like me who are at home going, reheat?
So reheat is you don't have it on your airliner, but it's a very efficient way of getting more power. So the EJ200 is a fantastic engine. So we generate something like 6 tons of thrust, what they call dry thrust. You go to maximum dry power. So that's the engine operating at the highest power setting you could get without anything else. So reheat, when you see an afterburner on a jet fighter, you see those flames out the back. That's basically when you inject extra fuel into the hot air that's come out the engine. That ignites, and that gives you more power. So we can go from 6 tons of thrust up to about 9 tons of thrust. So in Newquay, we're getting about 8 tons of thrust. For a car that weighs 5 tons, that's a lot of power. So that car will go vertically upwards.
And as they're rolling the car out, we get for the first time really a sort of a glimpse of the view that Andy will get. He's just sort of starting to, I think, nestle himself into the cockpit. But it's quite a narrow view that he gets. It's almost like looking through a letterbox, I suppose.
It is, and there are some side windows on the side, and somebody said at one point, is that for checking his blind spot? I think he'll be very, very surprised when he starts overtaking him. But he needs to look straight ahead, and he needs to be very clear about where he's going. So the view, when we came up with that design of car, it's very much based upon what he can see and where he can see on the nose of the car.
And again, for those that have joined us on web stream, the car, it's got bodywork in some areas, but there are other parts where the bodywork's missing. Just explain why at the moment it's not as streamlined as maybe it should be.
So what's very important here, so in the UK we're running on, it is one of the longest runways in the country, but it is a runway. So when we're in South Africa, we're running on metal wheels. On the runway, I think they'd be quite annoyed if we ran on metal wheels, and actually Andy wouldn't stop that well. So we've got rubber tyres. So we've actually got rubber tyres from a English Electric Lightning, which are very, very narrow. They're very narrow for an aircraft tyre, but they're not quite as narrow as the ones we have on the car. So actually the front bodywork doesn't cover those front wheels, so they're exposed, and likewise the rear wheel fairings that go around the rear tyres also are exposed. That we always knew that was going to happen. So those parts of the bodywork don't exist, but the fact we've got rubber tyres means that we get very good braking. So unlike in the desert where we only have wheel brakes on the front wheels, here in the runway configuration we have carbon discs on the front and the rear.
And I suppose because you're running at those speeds at sort of 200 miles per hour, approximately in a few moments' time, and it is, this is a live test. This is not a demonstration run for those who've just joined us. This is live testing going on today, and the data will be used to propel this car into greater speeds later on. But as a result of what we're doing here today, then we can see as the engineers pushing the car back, they'll be preparing for the first of 2 runs, I gather, and equally, when the engine fires up, I gather he's doing 2 runs with the engine fired all of the time. So this is going to be the longest single period you've run that EJ200 since you've been down here as well.
Yes, so this will be the longest we run the engine for continuously. So we're doing a drive round to the start of the runway. Andy will do a full power run, and then he'll come off the end of the runway, and then he'll turn around and come back and do that again, and then do that twice. So it will be the longest duration, that we've run that to, and it will be also the fastest we've run the car to date.
I hate to be the one to ask this question, but I'll ask it anyway. Is there anything that could go wrong?
I would say not. I would say I'm probably going to kick myself now because it was quite foggy this morning, and electricity and fog doesn't work that well together. No, I mean, we are very confident. So we've done some test runs here. The car will work. The car will go very, very well. I'm hugely confident that we go. No, so things that could go wrong. So Andy may miss the turning point. So it might be because of how we run the engine, and we're trying to go a bit faster than we were doing before. We're trying to come off the runway a little bit ahead of where the end of the runway is. So there's a taxiway that we'd take. If we go past that, then Andy takes the next taxiway, and we may have to stop the engine, help the car around the corner. Its turning circle isn't good even for a runway, and then we'll go back the other way, and it will get restarted a bit closer.
Okay, that seems fairly simple in that case.
You say the turning circle isn't great on this car. So for the uneducated, what is the turning circle of the car?
So the turning circle is a mere 250 metres.
Wow.
So as some of you may have witnessed this morning, as we move the car around, there is a kind of a 15-point turn we do to do a really tight corner. But actually on the runway and the taxiways, one of the routes we've been trying over the last couple of weeks or so, and Andy can drive from one end to the other and drive back down the taxiway and reposition himself at the start of the runway.
Well, as you can see, things are getting to a very momentous time. So that, for me, is the moment where I'm going to love you and leave you. I'm going to go outside, and I will be there to speak to Andy Green as soon as he's finished his run and get his first reactions to it as well. So enjoy. I hope it goes really well, and I'll be back a little bit later. Oh, and Bloodhound is go is the hashtag we're using. So if you want to get involved on social media, that's the one to use. So thank you very much for joining us, and I'll disappear now. Yeah,
Bloodhound is go, and of course the website is bloodhoundssc.com, bloodhoundssc.com. I saw a few moments ago, Mark Chapman, there was a sort of a vehicle arrived that had got a green box on the back of it. What's the green box?
So I would say it was Andy's packed lunch, but
he's a hungry man if it is.
No, so when I was talking about the air start cart, so that green box was actually used to be used to start VC10. So you see down the end of where people came in through, there was a VC10. So that's an air start cart for a Conway engine. Now what's in there is a small jet engine, and we basically run that, and the hose you can see going to the back of the car is an airline, and that goes into the Amad gearbox. There's an air start turbine there, so that blows the engine around. And so we're just about to check that, take the exhaust, open the exhaust flap and get that ready to go. And then that engine will get started, it will idle, come up to power and speed, then Andy will call when he's had clearance from air traffic. We'll go air on, and you'll see that hose inflate.
And we are hoping that we should, as and when we start to get a little bit of air traffic going on, or communication between Andy in the car and Jess, who is up in air traffic control. We were hoping that we might have had the chance to speak to Jess, but she's a busy lady today, and understandably so. So she is safely ensconced, Jess Kinsman, up in air traffic control, because she is the run controller, and therefore she has got a lot on her plate today, a busy thing to do, and she might have the best view in the house, but she doesn't really get the opportunity to enjoy it.
No, it's quite. I think we've been very lucky with the support we've had from Cornwall Airport here, because it's an unusual thing to do, to say close your runway and we'll run a car up and down it. But it's more.
So Andy, hands in pockets, looking very relaxed. Yeah, Andy, hands in pockets. He's looking very relaxed. He's been through this process numerous occasions, and therefore I suppose, as Richard Noble was referring to earlier on, when you drive these cars, these fast cars, all of the time, it does become a process. It becomes the norm.
It is. So what you're seeing Andy Green doing now is that he's now doing his final walk around checks around the car. So he's checking the tyres for any damage. He's just walking around to check there's nothing loose on the car. So things like the cameras, the aerials, anything that's on there that might fall off while he's driving.
And at the very front of the car, I think we just quickly saw in shot there, at the very front, there are two flags right on the nose of the car. I'm not sure whether we might be able to get the cameraman to head back down there or not, but right at the very front of the car, it looked like a Union Jack. There we go, super stuff. Union Jack, and as he zooms in, that's a South African flag. So just tell me a little bit about that, because I've seen flags on the front of land speed record cars before, but I haven't seen the South African flag, I don't think.
So it's traditional. There is one land speed record car that's run in South Africa previously. However, the tradition is that you have the nation of the team that's trying to break the record, and then the flag of the nation of where you're breaking that record. So if you look at Richard Noble's car or Andy Green's car, they've got the cross flags, which is the Union flag, and then also the Stars and Stripes of America. So they ran the car in Black Rock Desert. So running in South Africa on the Hackskeen Pan, we're very lucky that is the greatest track in the world that we could hope to run on. So we have the flag of South Africa.
And how long has that tradition been going on? Has that been going on for quite some time then, prior to Thrust 2 and Richard Noble, I assume?
Yes, I mean, it's kind of a tradition that, I don't know whoever wrote it down first, but it's kind of one of those nice things to do. So when records stopped being broken, so in the UK we used to break records on Pendine Sands, but then moved to a place like Daytona Beach and Bonneville. And that kind of is when that tradition started, of you had a British team breaking the record in another country.
You mentioned, the likes of Daytona Beach. You mentioned Pendine Sands. When you look back at the very beginnings of land speed record breaking, what we're seeing here is probably, without question, the most high-tech, the most professional car that has ever been built to break a land speed record. And looking back at some of the early attempts, they were brave people. You're taking what are calculated risks, and at any point that risk goes beyond what you're happy with, everything stops. The run stops, the run gets aborted. But in the early days, the early pioneers who put us to where we are today, it was an entirely different thing.
It was a very different. It was a very dangerous sport, but it's very much to do with how do you manage that risk? How do you go faster and faster? And yes, you're right, this is a very differently engineered car from even Thrust SSC. And the amount of analysis we've done before we actually started to actually cut metal is huge and phenomenal. But if you look at the risks, so the things like the forces and stuff are going up the square of the speed, so you go twice as quick, you're generating 4 times the drag, so there's extra load on that car, but actually the power requirement goes up with the cube of the speed. So twice as quick, 4 times the drag, but it's 8 times the power. So there's a huge leap, even to go from 763 Thrust SSC breaking the sound barrier to 1,000. We need a tremendous amount more power to get it. To go from 800 to 1,000, we treble the size of the rocket.
So that's the reason then why when we have something like a Bugatti Veyron, which can do 250 miles an hour, you can't just get 4 Bugatti Veyron engines, put that in a car and it will go 1,000 miles an hour, because the maths and the physics just don't make that happen.
The maths and the physics, but also the moment you start going above about 400, 500 miles an hour, tyres stop working, so you can't generate the friction with the ground, so the rubber tyres will just get thrown off the rim, so you end up having to go to a thrust car. So you can see all the land speed records that are running beyond Campbell in the Bluebirds. That was the last wheel-driven car, but even that was powered by a jet engine.
The wheels, we saw a video earlier on for the people that were on site here, but for those that are around the world looking at what's going on here, just tell us a little bit about the wheels that you're going to be running in South Africa. They are the fastest wheels in the world. You've almost had to reinvent the wheel to create that wheel. Just talk us through some of the enormous numbers of the forces they have to deal with.
So, I mean, it was pretty much the first job on the project was, we had how hard can it be to design a wheel? And then you'd look at the forces, and you've got a wheel that's going around at 10,500 revolutions per minute.
Per minute?
Per minute. So that means G, so how, as you fling things around, as you spin things around your head, you get that load on them. So that's 55,000 radial G. So put that in context, that's a bag of sugar weighs 55 tons. And with our original wheel design, we literally found we couldn't find a material to make that wheel from without it ripping itself to pieces. And so we had to think, well, okay, something's wrong here. We cannot do this. Is that the limit of the project? Have we set a speed that you cannot exceed? And what Bloodhound does that's quite different is that we change that problem. So the problem isn't making a wheel strong enough for Andy. The actual thing we're trying to solve is the car needs to stay on the ground and Andy needs to steer it. So we've actually changed how the car steered, and that allowed us to come up with a different wheel design. And that wheel design, working very much with the likes of Rolls-Royce, it is very much like a gas turbine disc. So the inside of a big jet engine. And those wheels are symmetric and they're made out of aluminium, and they'll be perfect. We actually spun test them in the rigs with Rolls-Royce and Derby. They test jet engine parts in. So it's gone to full speed. Now what was interesting about that was that we always had this, when they test a gas turbine, they run them under vacuum, because gas turbines have big fans on them and they churn a lot of air.
So under vacuum, for the younger listeners, there's no air where they're running it. They suck all of the air out and do it that way.
They suck all the air out, because as it churns the air, it's like a massive paddle wheel. It generates a lot of heat, and it generates all this heat. And they said, well, you've got a wheel that you've got no blades, you've got no paddles, it'll run just fine. When we ran that engine, when we ran that wheel in that, we basically got to 10,500 revolutions per minute, so as if the car was doing 1,000 miles an hour. And when it was doing that, the outside of the wheel heated up to almost 100 degrees centigrade in something like 3 seconds. Wow. Just shearing the boundary layer, so just shearing the thin layer of air around the wheel.
So you mentioned radial G earlier on, and again, I'm conscious that we're going to have potentially a young audience that are out there and looking at these fantastic images that we're seeing being streamed live over the net. Radial G for anybody that's younger, the easiest way to say that they felt radial G is a roundabout.
So imagine going on a roundabout and somebody throws you around the roundabout. If you sit in the middle, you don't feel very much force on you. As you go towards the edge of the roundabout, you hang on. It's a fantastic. Your legs fly out and you grip on, and it's wonderful. That is what radial G is. So if you imagine at the edge of the wheel, that's as if a bag of sugar would weigh 55 tons.
So it's trying to rip itself apart then, I'm guessing.
Indeed.
So the team look as though they're almost ready now, are they, potentially to get Andy in there? We can see his crash helmet, which by the look of things has got the Union Jack on it, but also has, of course, some of the key wildlife that will be there out in the Kalahari. So there's still this fantastic association between the project, and we can also again get a really good glimpse of that onboard shot that we're going to see. We've got a range of cameras that are on board this car as well, so we're going to be able to see things as well, and look back at some of the replays as well that we see as the car heads down the runway.
Indeed, I mean, the beauty of this project, the whole idea of this project is that we can stream both live video and data off the car, and we're trialling some systems here today, and actually running down the runway at Newquay gives us that opportunity. So yes, that there are various camera shots that we'll be collecting and streaming live, but there are also numerous other cameras on the car that we'll collect post-run and be able to share that later.
And looking on the screen now, you've got all of those names down the side of the car, and I think it's worth, again, just confirming this for people who've just joined us on live web stream, is that a lot of these companies are involved with the project, but the fundamental of the project and some of the reasons why they are involved and have their name on the side of the car is because they want to engage, and they want this project to inspire the next generation of scientists and engineers that are going to go into their businesses as well, because it's not, its main goal is not going fast, it is inspiring that next generation of young people.
Indeed, and when we started, sort of 8-10 years ago, people go, well, you'll just say that, won't you? But actually, when you look at what the project's done and the inspiration it's having now, I've been introduced to 3 people so far today that actually said, I'm doing engineering as a Bloodhound, or I'm doing science subjects at A-level. The project's now in its 9th, 10th year, and you're actually now to see that group of people, that cohort of people actually find science exciting. And there is no better way in this project. I mean, when we start to see this car run down the runway in a few minutes' time, when we saw it start up for the first time only a week or so ago, the feeling that gives us is amazing.
So we can see that Andy is now not only inside the car, but he's now starting to put the crash helmet on. We've been hearing a little bit of radio traffic between air traffic control in our studio here and the start team. So the start team are in the process now, I suppose, Andy, of beginning to get things going and beginning to do the final checks before the car heads down the runway.
So Andy, we're there just getting himself comfy. He's going to be strapping himself in, getting the helmet on, and he's now basically just waiting for clearance from air traffic that's basically to tell him that the recovery teams are in the right place on the runway. Once they're in the right place on the runway, he'll get the clearance to start the car, so he'll then signal the start team to start.
So we're just hearing that around about 2 minutes time that we will start to begin to hear a little bit more radio traffic. So the comms are coming through. We just can see that Andy is beginning to put on his gloves, and while Andy is starting to do the final sort of checks and balances, just talk us through these final few processes that he'll be going through. So he's now inside the car, he's now got the crash helmet on, so I assume the sort of comms checks that are going on and the final checks that all of his instruments are working.
So he's powering up the electrical systems on the car. He's doing final comms checks with his start team. You can see him just holding the canopy hatch. So once he's in there, he'll signal he's fine for that. He'll put his breathing air on and the radio. He's now signaling for the hatch to go on.
Start team tower recovery are ready.
Recovery ready, that's copied, thank you.
So just confirmation over the radio that the recovery team, I heard recovery there. Now that's the team at the bottom end of the runway, is it not?
So it's basically, there's a receiving team at the end of the runway, so basically the idea is that Andy will drive off the taxiway at the end of the runway.
011, wind is 2 o'clock, 6 knots.
Bloodhound copies, plus 13, 1011 and 2 o'clock at 6 knots. Bloodhound will be ready to start shortly and requesting start clearance.
So that's a sort of weather read back by the sounds of things, and I just heard the word start approved there, so that means the air start now will power up?
Yep, so they've now approved him to signal to the start team to start the air start. So you now see that go through its startup process.
So startup process continuing, and we can hear that. I can hear that in the background. I mean, that absolutely. You said it was a jet engine on its own. You can hear that familiar whirl as it starts to fire up.
It is quite funny. So as it starts up, you then, when we start the EJ200, you almost can't notice any difference. It's quite fantastic.
Now that's noisy. When the car is trying to attempt to go flat out at its ultimate target speed of 1,000 miles per hour, or 1,050 is its peak speed that it's been designed for, I gather, it will be running a jet engine. It will also be running a rocket engine on that occasion. So in terms of decibel level, how much more does that decibel level go up when you run the jet as well as the rocket?
That picture you saw at the rear of the car isn't the place you want to stand. So the jet engine and the rocket, we're talking about 180 to 200 decibel. It is phenomenal. When we did the rocket firing here down at Newquay, and we fired the rocket in the hardened aircraft shelter, that actually set off a load of car alarms. So it's pretty noisy.
And I did hear one statistic, correct me if it's not quite true, that on the day that this car runs, I think we can get some more communications from the car. Hang on.
Roger, stop team, air on, air on.
So he's now asked for the air to go into the air start turbine, and that will start winding up the EJ200, and you'll start to see heat haze through the back of the engine.
And as I say, I heard a statistic, I don't know whether it's true or not, but when this car runs and looks to try and break the record, it will be the noisiest thing on earth that day.
I think we looked at it, and the only things that would be noisy would be something like Ariane or SpaceX taking off, or a really big volcano. So it's going to be very noisy.
And looking at the conditions, we mentioned ideal, there's not a lot of movement on the windsock, so we're going to be good to go, surely.
It's perfect conditions for today.
Bloodhound, go ahead. Stand by. Start team with Bloodhound. It's a good start. Clear disconnect. Joe from Bloodhound. Just for info, we had the speed reading initially stuck up around 150. It has now sorted itself out during the start.
So by the sounds of things, just as a very small minor problem with just a speed reading by the sounds of things, which seems to have sorted itself out, and that's what these tests are about, Mark.
This is a prototype vehicle, so what people maybe think this is just a show and tell. No, this is a proper engineering exercise. Seeing Andy going through his checklist, going through all the things he needs to do.
So that final checklist, it sounds as though there was final disconnection there of the chocks, so I think very shortly we will be seeing Andy taxiing down what is Delta runway here at Newquay Airport, called Cornwall Airport, Newquay. Let's listen to Andy Green in the cockpit.
Fire 30.
Bloodhound Tower, approved to drive to the 1-2 threshold via the 30 threshold.
Bloodhound, we'll be driving initially down the Delta to the 1-2-30 threshold. We'll call crossing. Start team. Brakes on, chocks away.
Copies.
So the moment's coming, Mark. We are about to see very shortly the car roll out onto the runway for the first time. We heard the communication there. Andy will head down the Delta taxiway and then down towards the 30 threshold, as it's known, which is at the bottom end of the runway. He's going to come from the opposite end, but the 30 threshold is the far end of the runway, where he will cross over the runway to then start taxiing down the opposite side, ready to line up.
Yeah, so what you'll see him sort of disappear down over the slight hill here at Newquay, and then he'll go around the end of the runway and then drive all the way back. You'll see him going down the other end, and then he'll position at the start of the runway, and then he'll get for clearance and he'll go for a run.
This is engine arrow, message over.
So We can see the car taxiing away down the Delta runway. You've been here for the static tests of this car, for the tie-down test where we physically stop the car rolling but run the engine up. You've been here for the first dynamic tests as well. And what does it mean for you today to be able to do this? You've seen this before, but it's the first time we've done it in front of the public and the world.
I think people are going to know how exciting this is. Even seeing it's like this, this is a fantastic thing that is being put together out of a team in Bristol.
So we will pick up on a little bit more radio traffic that's going on as Andy Green makes his way away from the start area down the Delta taxiway and on towards the 30 threshold, where he will ask for clearance again to cross that 30 threshold, because of course that is runway approach for any other aircraft, which in theory will not be around here at the Cornwall Airport Newquay, because they have closed the runway for us for an hour and a half to be able to conduct these two high-powered runs. And let's not forget, this is the public debut of Bloodhound SSC as it heads down the Delta taxiway on towards the 30 threshold and is very shortly going to conduct a couple of high-speed runs in excess of 200 miles an hour, accelerating at around about 1.5 G as well, Mark, as well. So not sustained for long, but that's still a significant amount of G for a short period.
It makes most cars look pretty shabby, actually. We've been down here before, and this will do 0 to 200 in around about 9 seconds. And so yes, for the first up to 60 to 100 to just over 100, then a very fast road car can kind of keep up. But then it just really takes off, literally.
And we can see the enormous crowd heading towards the viewing area. Let's hear some more from the car.
We've arrived in our location and established. Over.
Star copy, thanks.
Crowds pouring out. We were expecting 3,000 to 3,500 here, Mark, and this is just the first of 3 days where we're doing this. We're doing a game tomorrow with a different batch, and school children, you could argue the most important audience, 4,000 almost, that are going to be here on Monday. In your wildest imagination, could you, at the very beginning of this project, really perceived how many people it really has captured their imagination?
Cross the 30 threshold.
So that's only just going around the end of the runway, so he'll now start that drive back along the northern taxiway to come back. You asked me what excited me. What's going to excite me actually is seeing other people's reactions. So this is...
Hotel, Roger, once vacated 30 threshold, you're approved to drive down the Alpha taxiway to Alpha 2.
So that's only giving permission to go down to the other end of the runway. Yeah, it's people's reactions. So when we saw this car start up a mere 2 weeks ago, and then when we saw it run for the first time, the dynamic tests, I think it's stunning, and it takes my breath away. But actually to be able to share that with the people that are here over these 3 days, and actually to the children that are here, to see their excitement, because I don't think there is anything that you've ever seen before that prepare you for what this looks like.
So we can see him heading down the Alpha taxiway now. All of the people here at Cornwall Airport Newquay making their way down towards the viewing area, and you mentioned at sort of the end of the runway it sort of drops away. We can just see the tail fin of the car, which is I think one of the most beautiful things to see on that car. Just tell us about the job of that tail fin. What's the job that does?
So it's very simple. It's to keep the pointy end at the front. It's a bit like a blade you see on the back of a feather on an arrow. What this car's different is that we can't have this car too stable. So one of the things people are asking, what would stop this car from running? A really high side wind, a really high crosswind, and it'd be like a weathercock, and Andy would struggle to steer against it.
This is Thunderbolt. Thunderbolt and Sunbeam will move to the agreed position near the entrance point for Bloodhound, 10 metres or so further forward. Over.
And we can hear the rest of the team there on radio comms as well. So this is not just about Andy, this is just about making sure you've got all of your team positioned in the right places to conduct their duties as we conduct what is a live test run.
So very much. So us being down in Newquay is also to do with testing the car, which is obvious, and testing Andy, but actually to test the team and to train the team. And there are very few opportunities we get to do this, and this is a fantastic opportunity.
And it's to make sure that they all know what their job is, what their remit is on the day, because when you've done that and you've had that opportunity to practice it, then the team sort of clicks, and it needs to, because you need to hit the ground running when you get out there into what are very, very difficult conditions. I think we can hear a little bit more, can we not, from Andy as he begins to head down towards the bottom of Alpha taxiway, where he will then line up at the bottom of runway 12, so he's got to cross the 12 threshold, and that's a curve that will bring him round, and then he needs to line the car up, I'm guessing, on the centre line, because we've heard from you that the turning circle on this car is 250 metres, so he won't line up at the bottom of the runway because the turning circle won't allow him to. He has to move up the runway a little bit.
He'll go up the runway a little bit, but then he'll hold and get permission to go, and then he'll put his foot down.
So we ride on board with Wing Commander Andy Green, the only man in the world who has travelled supersonic on land, having set the existing land speed record in Black Rock, Nevada on the 15th of October 1997, 20 years ago, as he now heads onto the 12 threshold and is about to line the car up at the bottom of the runway. So we will hopefully get some final traffic from Andy Green as he begins to line the car up, ready for the first of, let's not forget, 2 runs here at Cornwall Airport, Newquay. Beautiful sight, and well, this has been a long time coming, and the car looks absolutely fantastic, Mark.
I mean, I think just looking at that at the moment, the way the weather's picked up during the morning and it's just got better and better, I think it looks stunning. That's Andy pretty much lined up on the runway.
So the car is in position.
Clear to roll. Wind is 2 o'clock, 5 knots.
So the needle you can see in the middle of Andy's cockpit there, that is his speedo. So you'll see that needle as he accelerates.
So Bloodhound is go. Beautiful sight. You can hear the cheers. I can even hear the cheers and the applause in the background. Wow. I mean, that is quite something, Mark. You know, just a few seconds of reheat on the jet. Flames coming out of the back. That fantastic efflux out of the back. And Bloodhound SSC has accelerated from 0 to 200 miles an hour in 8 seconds. And as we said, 1.5 G.
I mean, it is. You know, I still get goosebumps when I see that, and I've seen it a few times now. It is amazing. It isn't like an air show. It isn't like anything you've ever seen before. You're seeing a car on a set of tyres going down a runway faster than anything you've ever seen before, and in such an impressive way. And I think it's a huge privilege to work with the guys that have actually put this together and are working on the car today.
And some great onboard images as well that sort of really give you an idea as to just how confined that cockpit is. And when we think about where you're going to be operating this car and looking to try and achieve its maximum performance, a very harsh, a very warm environment, a very cramped cockpit for him. He's going to be in there for quite a period of time. It's not a nice working environment.
So the biggest thing that Andy was worried about was noise. So when we first...
Approved to transit from the that's 2 to 30 threshold and around 2. Okay.
So they've just done a quick walk around check around the car. So basically the engineers on the receive team, what they've done is they've just looked for any damage on the car. They've looked to check that things like the cameras are still in position, that we haven't left any debris on the runway. And now Andy's got clearance to start turning the car around and going back down a similar route to what he's done previously to reline up on the runway.
Oh, so that's quite a quick process then. I thought that might be, you know, a longer process, but already then run number 1 done. He's starting to now think about the second run of the day and gathering that data again.
Yes, yeah, it's very much. It is a very slick process now. You know, we've been here practicing for a couple of weeks, and there are a couple of issues with going around various corners, but we've got a route now that we think Andy can drive through, and we've tested out a few times last week, and I think very easily Andy will be able to get back, and he transits across the threshold of the other runway, down the taxiway, and he crosses back across near the airport terminal.
So everybody says that the EJ200 is a remarkable piece of kit, and he's taking it around towards the bottom section of the runway as we're here ready to head up back through the 30 threshold, down what will be, I think he's now coming back down Echo to Charlie, is he not, where he'll cross across the runway and then go back down to Alpha.
He kind of does a figure of 8 actually. He's kind of, imagine kind of a figure of 8 race circuit. So he's driving fairly slowly around the figure of 8, then he'll line back up on the runway. When this day is just getting better and better, you look at that, the car in the sunshine.
The colours of it, you know, just work. You know, I was never a fan of the colour of Thrust SSC, the black car. I thought Thrust 2 looked better in gold, but for me, just the pure colour of that car, it works.
And it was kind of an accident. It was kind of, when we very early in the project, we said, well, we needed to have a colour. And
You're approved to cross the runway. Echo to proceed to Alpha and hold Alpha 2.
So confirmation that Andy Green is clear to cross. Echo to Charlie, and then onto the Alpha taxiway. So that's the instruction that will allow him to turn right in a few moments' time and move across the runway. And we can see now on the screen, yep, he's complying with the instruction from Jess Klinsman, who is the run controller up in air traffic control here at Cornwall Airport, Newquay. So over the Echo to Charlie, onto the Alpha runway, and that will bring him back down towards the bottom, ready to complete run number 2, Mark, and that's not that far away.
it's not, so we're probably talking about 2-3 minutes till him being ready to actually line up on the runway again. And as we saw last time, once he puts his foot down, then it really does go. We're talking about he's on the power for maybe 5-6 seconds, and then reheated for about 3-4 seconds with the diamonds out the back of it. And I think it will just look stunning as he comes down again.
So what is it that forms those diamonds out the back? I saw them on run 1 when it was on the full reheat. What forms the diamonds?
So what you'll see is that when Andy goes from stationary to actually start to put the power on the nozzle, those petals at the back change their shape, and they're basically controlling the airflow within the engine. So you don't want to have supersonic, so air faster than the speed of sound within the engine. So the nozzle moves to basically to choke the flow, to slow it down. And then as it rushes out the back, it accelerates hugely, and you'll get these diamonds, which are actually shock waves. They're supersonic shock waves within the exhaust out of the jet engine, and you can see that in the flame with the very bright diamond shapes you see.
And the flame out the back, in terms of the temperatures coming out the back of the car, clearly hotter once you get the rocket motor in there, but just with the EJ200 jet engine.
So the thing I find fascinating about a jet engine, so the flame inside the jet engine.
Line up, runway 12.
So that's Andy just about to line up. So I mean, the flames inside the jet engine are a higher temperature than the metal that around it can withstand. So actually they cool all those components. So it's actually about 2,000 degrees centigrade. So it's much hotter than inside a volcano.
So there's actually, despite the fact that there's lots of combustion going on there, there's cooling going on at the same time.
There is cooling, but the cooling air is about 600 degrees centigrade, so it's not cooling as you'd know it.
It's warmer than my oven at home, put it that way. So he's just now heading around the final part of Alpha, lining up onto the bottom of runway 12, and this will be the second ever run of Bloodhound SSC in front of the public here in the UK at Cornwall Airport, Newquay, down in the very southwestern part of the United Kingdom. And this car, it is a live test run, ladies and gentlemen. This car is being run in front of the public for the very first time. 250-metre turning circle means that Andy has to utilise all of the edge of the runway before he then comes back onto the centre line, part the way up runway 12 here, which gives him projection into a slight southwesterly direction. So we're 120 degrees from north, magnetic north, there or thereabouts. So the car's lining up on the runway. Final confirmation should be coming through from ATC.
Turn tower, clear to roll, wind 2 o'clock, 5 knots.
An absolutely astonishing sight, ladies and gentlemen. The second ever public run of Bloodhound SSC at Cornwall Airport here in Newquay. And Mark, to me, with my uneducated eye, that looked like another fantastic run.
You can't fault it. I mean, I was going to say, it looks quick, it sounds quick. I mean, you can feel it. You can feel the noise. And just to see, the thing that struck me over these last 2 weeks being here is how effortless that car looks. It looks like if you just let it go, it will just keep going and going and going all the way to break a land speed record.
So now the process is that Angie will now sort of sit and let the jets cool down, I assume, for a minute, and then you sort of go through the process of turning all of the systems off.
Yeah, so basically Andy has to drive the car around, so he'll drive it back to pretty much where he started, and then we'll then start doing the cool down process. So Andy will let the jet idle for a bit. We'll do some checks with the engineering team. He'll then clear the car to be, we'll make sure there's no debris left on the runway, so they're doing a quick inspection now.
I didn't hear any of that, over.
So you can see them now just looking at the wheels. You can see some actually some.
Bloodhound is now on the bat.
So now I've done the checks, they're now clearing him to go. And that slight, you can see some slight smoke on the front. That's from the carbon discs. So those disc brakes will be getting to between 700 and 800 degrees centigrade. They'll be glowing absolutely white hot as he brings that car to a halt.
And those carbon discs, they are, we see carbon discs on Formula One cars, but this is not a carbon disc off a Formula One car. This is a disc that has been built bespoke for this car and just for these runway runs as well.
So these are AP Racing's produced the disc and calipers for us. So they are, the speeds we're talking about is 200 miles an hour. You see cars at Le Mans and Formula One's approaching that speed. But this...
You're to cross the 30 threshold and proceed down to Alpha Taxiway.
This is a 5-ton car. There's a huge amount of energy. And you can see that when we'll see the on-car footage a bit later, see those discs really working hard and stopping Andy.
Yeah, so the runs completed, the car making its way back down towards the area where it was positioned earlier on. So, a fantastic opportunity for the people that are gathered here on site at Newquay, of which, for those of you watching on the World Web Stream, is around about 4,000 people almost that we've managed to cram in to Cornwall Airport, Newquay, and we sincerely thank them for their support and assistance. And even going slowly, it's a piece of beauty as well, Mark.
It looks. People say that if something looks right, it is right.
Yeah.
And I think, when we first came up with this designer car, people go, well, we're not sure about the shape, and the intake looks a bit strange, and the fin looks a bit big. But when you see it in there and you see it going, it just looks purposeful. And
it's fair to say, when we look at that side profile, that rear wing, there is sort of other elements to it that will go onto the car as and when you need them as well. So even the rear wing is not in finished configuration at this stage.
No, so there's another strake that goes on ahead. So if you like, you follow the profile of the fin going forward. And that's very much where it fares into the car down the front. So, making his way back down the Delta taxiway, where we saw him previously across from Echo to Charlie and onto the Alpha taxiway, which brought him down towards the runway 12 threshold. But this time he will come all the way up the Delta taxiway, and then when he gets up to the top, that's when the engines will go off. And, well, then I suppose the hard work starts for your team again, which means, downloading what you need off the car, double checking all of the componentry and everything else, and looking back at that data, analysing that, because I'm assuming you're going to use some of this data from the live test runs today, and that might affect what you do on Saturday when the car next runs. Correct, yeah, and you can actually hear Andy starting to taxi towards us here in the studio. Yes, every one we do, we gather data. We're not doing this for fun, if you like. We are gathering genuine data every time we run this car, and we're using that to influence the next runs. So these runs will have been quicker than the runs we did over the last couple of weeks. And then again, we'll look to push that, and we'll look to see where we need to get some more information.
It is really sort of a rolling laboratory, a vehicle of exploration. And so Andy is making his way back in towards our studio area, and well, as we look towards the car just coming up towards us now, beautiful shots as it now completes its run and starts that process, as we hear, of the engine shuts down. So engines will shut down, the team will then go to work. You can hear that whine, and just talk us through that whine. Why do we hear the whine when the engines are shut off, Mark? The same as we do when they start to ignite.
So the same thing with when you get off your airliner, there's an awful lot of energy. So jet engines are fantastically efficient, and that they keep spinning. So that whine you're hearing is the internal components, the turbines and the compressors, still spinning, although there isn't any fuel going in there. And you'll hear that, and it will take a while to wind down. But actually, that's really useful for the engine, because that draws an airflow through the engine that starts to help cool it down.
It's worth noting that whilst this is great for you to learn a bit more about the car as engineers, this is vital cockpit time for Andy as well, because Formula One drivers will get thousands of laps in over a whole course of a weekend and the whole course of a season, from today to when potentially this car breaks the record and achieves its ultimate goal of not only inspiring a load of children, a load of children that science, technology, engineering and maths are great subjects, and they will and do get involved with, but achieves its peak speed. We've only going to see Andy in that cockpit for a couple of hours.
It's no, so 0 to 1,000 to 0 is something like 1 minute and 3/4. So the engines we have are, we're very fortunate the UK MOD has loaned us the engines we're using. They were out of the UK flight test program for the Typhoon squadrons. They only have 10 hours left on them each, if you like. However, for us that's a huge amount of time. The thing that we have to be mindful of is how many starts and stops we can do. So the things that, if you like, that age an engine, if you like, is how many times it gets hot and how many times it gets cold.
Those heat cycles.
Those heat cycles. So while we've been at Newquay, we've started this engine probably about 18 times, and we've probably done something like the low 30s in heat cycles. And then we'll only be looking to do, for the whole running of the car when we start going to a desert, there'll be about 60 heat cycles in total for the whole duration of the project to go from stationary to 1,000 miles an hour. So yes, if people go, is there another reserve driver? Well, actually, Andy needs as much time in that car as possible. He needs to be able to work on that and find all the things he's been doing the weeks he's been here running the car. And that's actually key to part of how the team works.
It needs to be, you never quite get to it, the amount of time that he puts in there, but it needs to feel like it's home for him, and at the moment it must still feel sort of a bit strange and a bit unusual.
We're always learning stuff about the car, so things like, we're very about noise, so when he's running the car, that he's sitting right under the jet intake, so there is no jet fighter that has the pilot literally underneath, where we've got air rushing into that jet engine at huge rates, is right above his head. So there was concern that would that be too noisy, would be too much vibration, would we need to put sound deadening in there, all those things.
Yeah. But
actually Andy's saying no, it's better than he thought. There are lots of things on this car that he's going, actually that works, or could we do that differently, or could we change those switches? And that's exactly why we're down here.
And I suppose as the test program ramps up, and we heard from Richard Noble earlier on that you will be running the car in 2018 at very high speed. He was, and understandably so, not drawn to what that speed would be or where that would even take place, and we fully respect that. But once you get to that stage where you're increasing the speeds on each occasion and looking back at that data, every single test therefore becomes entirely different, and the car's doing different things, and Andy and yourselves have to learn all over again.
Yes, and that's, if you like, the joy of the project. It is a rolling test, but it's a laboratory. We are always learning. So with the speeds we've done over this weekend is going to be around about 200 miles an hour. There will be the limit of what we can do on a runway with a rubber tyre. So to go faster, we'll need a desert, and to get data, provided we get above, as you start to approach 400 miles an hour, things like the wheels, so the aluminium wheels, they'll stop working like normal wheels against the deserts. They start to work more like rudders. And then again, so you get a huge amount of data at 400. Then as you approach the speed of sound, so we believe with this car and its current configuration, we could easily get to somewhere upwards of 600, so potentially even 650 miles an hour, depending on how that works. But it's the great unknowns. It's those things. It is a prototype vehicle. It is a whole test program, and it's looking to, when we start running in the desert, how we see that drag, how we see those things work that you cannot do down here.
Okay, so with the car now just being inspected by the team, Jenny Gow is down there, so as and when we get the opportunity, Jenny will be straight in there to gauge some reaction from Andy Green. But before we do that, we've got some fantastic replays of those two historic runs from the car, and here's the first run of the car. Mark, just talk us through it.
So if we're looking at Andy, so Andy's applied full power. The engine looks after itself. We're very, very lucky with the EJ200. So as he puts his foot down, you'll see the nozzle change configuration, and then as the engine builds up speed, then you get the reheat, so you see the flames out the back. As he comes out of reheat, the nozzle closes and then it opens up again as he goes into idle.
I spotted there, when he got to, of course, half the way along the runway, where we had that Echo Charlie Alpha cross of the runway, you could just see a bit of movement in the car there. So that's the bumpiest part, I assume, of that runway, where you get the
It is
crossover.
bumpy. You just see it there in the rear footage. It's actually, people go, how much, when you look at the springs on the car and the dampers on the car, people assume how they're going to move. No, this is massively stiff springs, but actually they work pretty hard, and I'm very lucky that we spent a lot of time working on that suspension geometry, and it's worked beautifully. I mean, it's levelled out all those slight bumps on the runway.
I suppose it's the suspension, it's the damping in particular, I guess, is it?
It's the damping. You wouldn't want to be porpoising with a car that's capable of doing 200 miles an hour in 9 seconds.
And again, I just don't get tired of it. You could show me that replay all day long. Forget what we're doing in the studio. We almost don't want any more guests. Just keep running that through, and because it looks great, and a great onboard as well as we look on board.
So if you look at that speedo, so that white needle, that is going up to over there. That's about 200 miles an hour he's going up to. So it accelerates like nothing you've ever seen before.
And it's amazing that in that short period of time, we really don't get the impression, because we're looking out through the cockpit and looking at those dials, but you don't get the impression of the work that Andy is doing whilst all of that is going on. I was captivated by the image.
So he's sat there, so he's managing things like brake pressures and brake temperatures, and as he brings the engine up, checking things like fuel flows. There will be steering going on, so even a very slight crosswind, he will have to correct the steering of the car as he goes down the runway. So there's a huge amount of input, there's a huge amount of work, even those brief kind of 9-10 seconds. There's a lot going on. Then when he comes in to stop the car, he needs to be careful about brake temperatures and brake pressures. He doesn't want to, this car doesn't run ABS, so it's down to Andy monitoring what he's doing.
So we've had a quick look at the replays of the first run. I think we can probably go back and look at some replays of the second run as well. Are there any differences that you can pick out from what you've seen happen previously with the car? Any differences from run 1 to run 2?
I think run 2, the second run, looks like he didn't hold the reheat on for quite so long, but I mean it looks stunning. I mean that view we got from it going down the runway starting looks absolutely fantastic, and you get a real idea of how quickly it's putting on the speed. It's like a greyhound, not a bloodhound.
It certainly accelerates very, very quickly, and you can I suppose you can spool up the jets a little bit quicker here on a tarmac surface than you ultimately might be able to do when you're running in the desert, because what you don't want to be doing is sucking in lots of air off the desert floor straight away, and all of that dust and detritus.
So one of the things we looked at, particularly with where we position the intake, was very much looking at what would happen when you start operating that jet engine, as to where it would be sucking air from. So actually, with it quite high up, we don't think we're very sensitive to debris and dust coming off the desert. But actually, it sounds silly, we've actually looked at the dust. So if you remember a few years ago, there was the volcanic ash, the aircraft couldn't fly through the ash.
Yeah.
That was due to that dust that went through the engine. As it goes through those huge temperatures, 2,000 degrees, it would actually become glass within the engine, block up those cooling holes.
That would not be good, would it?
And that would not be good.
Even as somebody that doesn't really understand jet engines, I know that wouldn't be good.
But no, we've tested the dust that comes off Hack-Scheme Pan. It is very fine. It's like talcum powder. It's like nanoparticle sized, and it will just blow through the engine. So we're not massively concerned with it ingesting the dust off the surface.
Looking at the onboard shot there, is that windscreen misting by the look of things?
It might be. We haven't, so this sounds silly, so we designed this car to run in a desert in South Africa. So I jokingly said when we were coming down to Newquay in October, we need to have some windscreen wipers on it. Luckily we don't need windscreen wipers, but yes, we have actually looked at how we could do demist. This is the rear view, and you can see that suspension working as the reheat comes on.
That's a great replay. I do like that one, because you can see the efflux coming back out. I think we've got one more replay that we can show before we head down to Jenny, who is with the car. And here we go, a long shot, Mark, and you can see the perfect conditions. You can see the heat shimmer. It's still chilly, it's still autumnal here in the UK, but a great long range shot of the car.
I mean, we couldn't have been more fortunate with the weather this morning for it to clear up like it has. I mean, this is just, it's a beautiful day down here.
So the car comes to a halt. That's its second and final run of the day here at Newquay, and Bloodhound SSC has done exactly what it's been doing since it arrived here at Newquay. It is ticking all of the boxes, it is performing as expected, and now it's time to go down to the car and Jenny Gow, who is going to gauge some reaction after those runs from Bloodhound SSC.
Yeah, absolutely. How thrilling was that to see Bloodhound in action? Andy Green is here. He's just trying to find out the actual measurements and the official timings for it. But Andy, just give us a first thought of how that was.
Brilliant. That is by far the most difficult profile we've done. It's the longest profile. Car was running for 21.5 minutes. So that's, it's designed to run for a 2-minute desert run, not 1 minutes driving around an airfield, doing the complex manoeuvring, and 2 high-speed bursts. This is a car meant to do supersonic speeds, and we're asking it to be a drag racer on an airfield. And despite that, the car did exactly what we wanted. 2 runs to, I reckon, just over 200 miles an hour. Let me just grab Joe when he's available.
Joe is here. Joe is the man with the official. Now, you don't know these, do you? You don't know the official timings, so tell us.
Between 200 and 210 miles per hour on that run.
Perfect. That's exactly what we were looking for. Lifting off at 130, just a shade over 130. As the jet engine's winding down, it peaks at just over 200, and the brake temperature's peaked at
750, 800, something like that.
That's because it's also not only making the 5-ton car go, it's also stopping the car. And we were actually seeing for the first time, not just smoke coming off the brakes, we actually had a tiny flicker of flame on one of the brakes. Very Formula One. The only thing is, this is a proper fast car.
Are there any, I mean, there's obviously a huge amount of data coming back for you to sort through. What were the key things you were looking for?
Obviously brake temps, as Andy points out, peak speed, there's other system-related stuff that I care about.
Those were key?
Yeah, those are the key ones, really.
Okay, Joe, I'm going to let you go. Thank you so much for joining us. So, Andy, that's all the key information that you wanted to know, all ticked boxes of that's exactly what we were looking for from this run.
Yeah, exactly. So, we came here to show the world Bloodhound is go. I can't think of a better way of doing it than that run. Not just a run, 2 back-to-back runs, longest runs we've done, the highest speeds we've done, most energy going to the brakes, and the car just went, yeah, I can do all of this. I'm designed for supersonic speed, but this I can do easily.
Just walk this way slightly, because I just want to see the cockpit from where you've just climbed out of, and this gorgeous car as well. Just come round on this side so you can tell us about it. I mean, when you're actually in there, it doesn't look like there's a huge amount of room, and visibility looks incredibly limited.
Well, there's exactly the right amount of room, and of course the visibility is to be following a straight line, 12 mile long, down the desert in Haxkin Pan in Haxkin Pan in South Africa. Very much the same way that we did in Nevada 20 years ago. So I don't actually need, why do you need side windows in the car? Well, in case somebody overtakes you. This is never going to be a problem in this car. It's more than enough. Astonishingly, even with the limited visibility, it is still more than enough for me to manoeuvre around some relatively tight corners on the airfield, to avoid the runway lights and all the rest of it, to line the car up and to actually make it look like. Let me just, because I still actually have no idea what this looks like. Let me just ask the crowd for a second. Everybody saw that? What did that look like? Because I don't get to see it. Thank you very much.
Everybody, can we give him a massive round of applause?
Thank you. Thank you very much.
Andy, from our point of view, I know I was stood there fortunate enough to be on the runway, and the sound, the sight, everything's so visceral. I mean, when you're inside, you can't get a real gauge of what we all think, but what do you feel? What do you sense?
A lot of noise. First of all, I hear the compressor wind up, so I can actually hear the engine noise, then the huge surge of power as the reheat comes in, 1.5 G, 30 miles an hour per second. It's the equivalent of 0 to 60 in 2 seconds. Now, forget your supercars, forget your hypercars, this is a high-performance race car. And that, of course, just keeps going. 60, 90, 120, got to lift off now. It keeps accelerating, 150, 180. Then as the engine winds down, the speed starts coming off. I'm already on the brakes, already starting to warm the brake pedal up, already starting to get that 40, 50 bar, starting to slow the car down, watching the distance counter wind up and looking for the turn cues in the distance. So tremendous amount going on in the cockpit. Quite a lot of, even for a relatively slow speed run like this, relatively high G loads compared to a normal road car, but the absolute confidence that this is, in my humble opinion, the best land speed record car ever made.
That is quite some statement as well. If you look back over the history of land speed and to get us to this point now and the future, I mean, how excited are you about what's to come?
Just cannot wait. Having demonstrated Bloodhound is go, we've now got a clear plan to go faster next year. We're still refining the details, so I can't tell you exactly when that's going to be, exactly how fast. Hold that thought, we'll get to you shortly. And we've, more importantly, got a car that's already proving it is not just as fast as we're expecting, it's working better, it's more reliable, it's faster, and the team is just brilliant, because they are why this is working so well. The engineers and technicians and scientists who created, designed and operate this car and ran it here today, they are the ones who deserve the credit. I'm lucky enough to drive it, but I am genuinely privileged to be a part of their team.
Cool as a cucumber, and as you say, the whole team is around us, so I'm going to let you go. I know you want to find out a little bit more and meet everybody else and talk to the rest of the world's media, but Andy, congratulations and well done.
Thank you very much. And thank you everybody for coming to share our very special moment with Bloodhound is Go doing the fastest ever runs here at Cornwall Airport, Newquay. It's been a real privilege for all of us. Thank you to all of you.
Ladies and gentlemen, one last round of applause for Andy Green.
Thank you, guys. I want you to do, we're going to do a little walk on the line this way.
Well, I did say that we were going to make history here at Newquay Airport today, and we've absolutely done that. We have delivered on that, and I'm sure that Bloodhound will continue to deliver as well. It was powered by the EJ200 jet engine, a remarkable piece of kit. So let's just have a look at Andy Green's experience in the Typhoon fighter, where you'd usually find the EJ200.
Here at Royal Air Force Coningsby, and I'm just about to fly in the Typhoon for the first time. Specifically, I want to see how the EJ200 engines work. These are the engines I'm going to be using in the Bloodhound supersonic car next year as we take the car up to a new land speed record and ultimately attack 1,000 miles an hour. Typhoon flight, and I've learned so much about these engines. No wonder they have the reputation as being the best jet fighter in the world. Here at Coningsby, quick reaction alert, 24/7 protecting the UK. They have got the best equipment in the world, and I've just watched it work. Amazing experience.
Well, great to hear from Andy Green there, who has just been talking to Jenny Gow, but Mark Chapman still remains with me in the studio. Mark, you're now going to have to go through all of that data that's been collected and re-prep the car ready for the same process again on Saturday. Just talk us through how this evening and tomorrow is going to look for the team.
So the first thing is just to, as Andy said, to congratulate the guys that worked on the car. Now, Andy did a sterling job driving the car, driving the profile we'd asked him to drive. You know, he is part of that team, he's part of that process. So we agreed last night and this morning how fast he was going to go, what kind of speeds he was going to work to, and he nailed those completely. And then what we're going to do now is prep the car. We're going to look at that data as it comes off the car, but then also go back through nose to tail, see if there's any damage, any things we've looked at. Things like the brake temperatures, go through those, look at the pads, all those things you'd normally do on a race car is what we do. It's just a bit bigger. And then before it goes to, we'll wheel it back to the HAZ a bit later on this evening. The hardened aircraft shelter, we'll put some dryers on it to make sure it's kept dry in the humidity, and then refuel it and charge the batteries and all those good things so it's ready to do the runs again on Saturday.
It's been an early start. It sounds as though it's going to be quite a long day for you before you eventually get back to your accommodation.
It is, but it's fantastic now to actually look out the window and see the people and the looks on their faces as we run the car. That is why we're doing this project. It's a fantastic privilege to be part of this team and to be part of a project that is that exciting. And actually, it makes me like a kid. Seeing that car down the runway, like you see it go, and it makes you like a kid again. There is nothing like it.
I've loved it. Now, an enormous thank you to the team, but in particular also an enormous thank you to all of our sponsors and supporters of this project that have made it possible to get to this point here today, and we sincerely thank them from the bottom of our hearts, because without it we couldn't have done it. Jenny Gow has made her way into the crowds, the throngs and thousands of people that are here at Cornwall Airport Newquay, to gauge some more reactions on those two historic runs.
Yes, absolutely. As you can see, Andy's just making his way down the queue of people who are stood here. They really want to meet him. There's lots of people waiting for autographs and all sorts of action happening. As you can see, there's people that ran all the way from the runway across to here to have a chance to meet Andy, to see him and to try and understand some of the science behind what we've been seeing today and all the engineering. I'm just going to come into the crowd because over here there's lots of people with all sorts of... oh, hello, how are you doing? Are you all right?
Yeah.
Was that fun?
Yeah.
Are you on your holidays?
Yeah.
Is it going well so far? Yes. 4 yeses, we like that. Well done. That's good stuff. Right, gentlemen, I just wanted a quick word with you guys. How was that, your first experience of watching Bloodhound and seeing Andy in the background?
It was a great, fantastic run. Did really well. Happy to see that he's breached 200 miles an hour.
Was it what you expected?
Yeah, a little bit louder, but yeah, good to see.
It was really loud, actually, wasn't it? Were you surprised by quite how loud it was out there?
Yeah, but it was fantastic. It was amazing to see such an achievement. It's really, really good.
Have you been following the whole journey of Bloodhound?
Yeah. We were at the launch event in London a couple of years ago. Went to see it in Bristol, being constructed. It was really cool. And the engineering teams are fantastic as well. They're so knowledgeable and they're so willing to give their time to talk to the public about it. So.
Yeah, it's not just, isn't it, about the land speed record, about the fastest vehicle in the world. It's also about educating people, bringing on a whole new generation, hopefully, of engineers. And you can see this gentleman has the model. Just hold up the model for us, sir. He has the model, and on the side it says, your driver, Andy Green. Andy is a Royal Air Force pilot. In 1997, he drove the Thrust SSC to the current world record of 763 miles an hour. They're going to, thank you very much, sir. They're going to look to try and get to 1,000 miles per hour in this very vehicle that you saw here today. Ladies and gentlemen, how was that for you? Enjoyable?
It's very exciting, and my young brother's part of the team.
Ah, excellent. What does he do?
He's one of the engineering managers.
So that's pretty cool. So you've got a family interest in this as well as just
so.
And when did you first start getting into Bloodhound?
When he started on the project a few years ago.
When it comes to understanding what's happening and engineering and stuff, I mean, it's pretty complex, but they're making it quite easy for us to get into, aren't they?
Yeah, very much so. It's a good publicity exercise as well, good communications exercise, and good for schools.
Are you surprised by how many people are down here today?
Nope, because I know the interest that's been generated in this, so I'm pleased with the crowd that's come out and the support that's been given.
Now, this gentleman behind you was just shaking his head saying he was quite surprised by it. I mean, it's a great turnout.
It's amazing, isn't it? Unbelievable.
Has it lived up to your expectations?
Yes, absolutely.
That's good stuff. Okay, I'm just going to come along here. Hello, how are you? Are you all right?
Yeah.
How was that?
Very good.
Was it exactly what you thought? Was it louder?
I didn't really know what it was going to be like, but it was very fast.
And where have you come down from today?
Near Middlesbrough.
Wow, that's a really long journey, isn't it? That must have taken hours and hours.
Yeah.
Yeah. But it was worth it?
Yeah.
Excellent. And next up for Bloodhound, are you going to be at every step of the way now?
I'm not sure, but I'd like to.
Oh, and are you together?
She's my daughter.
Oh, so Dad, I mean, how impressed are you by the fact that they're reaching out to all sorts of people?
Well, that's what is fantastic all about it. I mean, there is a superb event, and to encourage everybody, not just children, but everybody, get interested in engineering, it's fantastic. And makes you proud to be British as well.
Doesn't it? I mean, the land speed record is such a traditionally British record as well.
Oh, it is, and it's a one worth having as well.
Next up, hopefully in the future, we're looking at going really fast next year, and then final destination South Africa to see if they can actually break that land speed record. I mean, how significant is that for everybody, really, not just the UK?
Well, I remember when Thrust SSC broke the land speed record. I was working in Switzerland, and everybody knew about it. This is going to be even bigger, so it's going to be fantastic.
Good stuff. Well, thank you for talking to us. These guys are trying to get hold of somebody. I'm just going to make sure that Michael Cameron doesn't trip over as we walk down this line, because I want to try and get as many people on as possible, because so many people have just loved today and getting involved in it all. There's a big screen over there with a stage on it. I'm going to see if I can talk to these guys. Hello, everybody. How are you doing? You all right?
Yes, thank you.
Yeah.
Now, where have you come from today?
Ascot.
Oh, Ascot. That's just down the road from me. We could have shared a lift if I'd have known. Are you on your holidays?
Yes.
And how cool is what you've just seen? I want all three of your opinion. On a scale of 1 to 10, how cool was that?
10. 10.
10.
Pretty cool then. That's. I think that's clear to see. And you've got a front row vista, I suppose, of the car itself. What do you make of the car?
I think it's very nice because it's a very sleek model and very aerodynamic.
Have you been inside the education zone learning all about aerodynamics and engineering?
Some of it, not all of I haven't explored the whole area yet.
Plenty to look at, that's for sure. And what about yourself? What do you think stands out?
Just the size of it. It's so big. It's a lot bigger than you'd actually expect it to be.
And did you get you got a good view here. Did you get a really good view of when it was actually doing its 2 runs?
Yeah, I've got some good pictures and we got a video of it as well. So we can take them back with us.
And are you going to go back to school and tell everybody that you were here?
Yeah, I'm actually doing a project on it at school, so I can show everyone and they'll all know about it.
That's awesome. So does that mean that you quite like to go into sort of engineering and a science background?
Yeah, that's one of my interests. I like it. So yeah, maybe in the future.
And have you guys had a chance to meet the driver yet, Andy?
He passed us.
He passed us.
Passed us. Maybe he'll come and say hello in a little bit, if that's all right.
Yeah.
Okay. Thank you so much for talking to us. Enjoy, won't you?
Thank you.
Give everybody a wave because you're on the big screen and going around the world live. Let's come down here and see if we can talk to these people. Hello. Someone from the BWRDC. How are you doing? Are you all right?
Having a great time. This has been out of this world, hasn't it?
It's absolutely amazing.
What an achievement.
It's a real privilege to be on this side of the barrier, I have to say. But I mean, just tell me from your perspective what the run was like.
Well, what can we say? You know, something that's going over 200 miles an hour. As for starters, I know it's going to be progressive from now on in, but we're here with a load of cars that can do 200 miles an hour, but not like that.
Yeah, it was a bit different, wasn't it? I mean, 0 to 200 miles an hour in about 8 seconds, and then the deceleration taking even longer, really.
Yeah, frightening.
And you can just about see all the media have come in now. They're all taking pictures of the driver, Andy. I mean, it's just fantastic, isn't it, that Britain and...
Well, it's, yeah, a British effort completely. Your scientists, your engineers, your man. Is he a pilot or a driver?
Yeah, well, this is a good question. I've had this debate as well, pilot or driver. They're saying it's a driver because it is a four-wheeled car, but he is a pilot in his day job. So I think we can use either and be okay.
His skill is, and he's got to have a nerve of steel.
Do you know what? He got out of that car, not even a little shake. I mean, he is cool as a cucumber.
Fantastic. It is fantastic.
Well, thank you so much for coming down. I hope you've enjoyed it. Thank you for talking to us.
9-year-old Alex wants to design the next land speed record car.
Are you 9-year-old Alex?
The Vortex SSC.
Wow.
1,500 miles an hour he wants it to go, with 2 Typhoon engines. And the aerodynamicist and the chief engineer has already wished him luck.
That's amazing. I'm guessing then you're into, is it engineering or cars or both?
Both.
Both. And what is it about this project that's excited you so much?
Because it's been able to go one of the fastest cars in the world, and I've been interested in cars for practically all my life.
Who got you into cars then?
Mum and Dad, because they both like cars.
Love that. And when you look at this car, what does it make you think of?
Wow.
I love that. And when you saw it on the runway, what did you think? It's pretty spellbinding, isn't it? It's very special to be here.
Yeah.
And when it comes to going to school, we've just spoken to another little boy who's going to go to school and tell everybody about it.
When I go back, it'll be my birthday. I'm going to be bringing this in and tell them all about it.
Who else are you going to get to sign that piece of paper?
Try Andy Green and maybe Richard Noble.
Love it. Well, congratulations. I hope you've enjoyed it, and I look forward to reading about your challenge.
Okay.
Thank you so much. So that's the reaction from down here. A lot of excited people. Ladies and gentlemen, how good was that? Brilliant. Yeah, pretty good down here.
It's wonderful to see the reaction and the bloodhound effect. We heard earlier on today the bloodhound effect, and I think that anybody that's been here that has seen these historic runs being made by the car is at the moment really feeling that bloodhound effect, and that's the effect that we want to spread as well. So keep your tweets coming in. Hashtag bloodhound is go. Hashtag bloodhound is go. I mentioned earlier on that it's not just about the engineers and about the ambassadors, but one of the key fundamental parts of this project is our fantastic supporters that we've got, and I'm delighted to say that head of brand for Cisco, Terry Donovan, has now come to join us in the studio. Welcome along, Terry. We're all part of history now, aren't we?
What an exciting day. It has been amazing. How exciting to be here to see all of that in action. Amazing.
Cisco, vital in providing some of the video and networking systems that we're going to utilise as part of this project. So just sort of tell us about your involvement with the project, the brand, and what you're involved in the project for, because I know you run your own STEM programme as well, don't you?
Absolutely. So there's a few ways that we're involved. We really share a lot of the values that the Bloodhound team have in terms of reaching out in STEM subjects and inspiring new generations in engineering and maths and technology, and that really really is something that we share a lot at Cisco. So we really wanted to be part of this project, and we're involved in a few ways. So we're providing a lot of the technology that's kind of here today, helping us to get out to everybody out there and connect everybody with the action. We're also providing technology to the Bloodhound team back home in Bristol to help them to connect actually with all of their sponsors and with students across the globe. So really just helping to connect all of that. And then internally, we also already have a STEM ambassador group and network that are going out to schools. So we've trained a lot of those guys to go out. They know the Bloodhound story. They can take that to schools and really inspiring new generations and helping the Bloodhound project along the way. So really exciting to be part of it.
So a lot of those shared values, and also, some of that is to ensure that, you have that resource moving forward and those skills in your business in another 5 and 10 and 15 and 20 years' time.
Absolutely, very much so. Yeah, very much part of the passion and part of what we as an organisation are trying to achieve. Yeah. Absolutely. We have lots of other programmes going on, but everything very much about really inspiring those new generations, indeed.
Today's the first time, I'm guessing, you'll have seen the car run.
Yes.
As a newbie, we would know, the engineering team have seen some dynamic runs, but there are very few people that have seen that car run in the flesh until today. Yeah. Your thoughts on it?
Oh, it's just amazing. I mean, the adrenaline rush and the sound, I mean, it really got your organs pumping, you could really feel the speed and power. Very exciting. It's so great to look around and see everyone's enthusiasm, all the kids, looking on and wondering what they're going to be and how they could be part of projects like this and others moving forward. Really exciting.
And if we are as wowed as it as we are, with the experience in life that we have, for the children, for the actual people, we are looking for this to inspire and have that inspiration and that legacy that's going to continue. The wow factor for our key audience, you with your STEM ambassador, us with what we're trying to do, the wow factor for them must be enormous.
Oh, amazing, incredible. I mean, what more could you ask to be part of something like this? And it really is inspirational, and it really kind of offers up the opportunities that are out there for people to explore and get into, doesn't it? I mean, it's so exciting to see, all the wide eyes and hear all of that emotion with everyone here today. Really exciting.
Just tell us about the size and the scale of Cisco as a business. Now, a global business, which is enormous in reality. Just for the people that may be not familiar, just the scale of what Cisco do as an organisation.
Yeah, absolutely. I mean, we work in lots of different areas, and a lot of the technology that we're bringing to the Bloodhound team to help run their business. We are essentially a networking and video partner for the Bloodhound guys. So we're helping with essentially connecting people and through their business with our networking products, our security collaboration products, enabling people through WebEx and telepresence to, connect and be inspired and learn about what the Bloodhound program's all about. So, we have a lot of those products that are helping them, run the business and bring their story out to the world. So lots of networking, Meraki, collaboration, security, lots of different elements actually of the Cisco organisation that are really pulling together to try and help bring this to life.
And I assume, with the amount of supporters that we have, corporate supporters in the project, that some of those corporate supporters are probably Cisco customers as well, are they? So there's sort of cross-fertilisation networking going on.
Absolutely, it's amazing. This really is a subject that you can get so many people involved with. We've got a few of our customers here with us today, obviously. Very exciting for us all to be here and witness it. But yeah, it's really inspirational. And I know on our own, social channels and so on, there's a lot of engagement around this subject today. So excited to see the next steps. Excited to get closer to South Africa.
It's far more years than I would like to remember from when I was at school. But if ever there were an exciting maths lesson, something blue and orange and 13 metres long for me is the most exciting mathematics or physics lesson you could ever have.
Isn't it just? Isn't it just? It's incredible. And didn't they get to the end of that runway faster than we were all expecting?
Well, I knew it wouldn't last for long. It didn't last very long at all, and it's great to hear Andy's reaction as well. And it is a team, and when we say a team, it's not just about the car, about the engineers. It's about yourselves as organisations that are supporting us. It's about everybody that's on site here, everybody that's looking around and listening in on the live web stream as well around the world. You know, this is an enormous family, and the very reason that everybody is here today or is on the web stream is because they're passionate about what we are trying to do, which is push the boundaries, which is to try and leave a legacy, which is to inspire that next generation and hopefully create a new land speed record.
And we are one big family. You know, there's a lot of sponsors, a lot of customers, a lot of kids, a lot of ambassadors that are really taking the message out there. There's a lot of people really focused and inspired by this and helping to bring it to fruition. So yeah, exciting times ahead.
I assume you've been down to the BTC, to the Bloodhound Technical Centre, and seen the car in build.
I have. Yeah, it looked a bit different then than it does today.
It was the
all
last
in
time
pieces.
I saw it.
Yeah, the little components all coming together.
So what's the next thing for you after this? You know, obviously the car will continue to develop down at the BTC with lessons learned from this weekend. It will then go for its very high speed runs in 2018, location and speeds to be announced at due stage. Will you also potentially get the opportunity to see it do its world record runs?
Let's hope, absolutely. I mean, that's what we're all working towards, right? But in the meantime, our real focus is obviously to continue spreading the word through our STEM and Bloodhound ambassadors, and we're also helping to make sure that people are updated on the story of Bloodhound. So there's a channel called Cisco Bloodhound TV, and we're working with the team to make sure that there are regular episodes keeping people updated, and there have been to date already on all the developments that are happening, all the new stories that are, you know, all the milestones that are reached within the team. So we're going to be continuing with that, making sure that everyone can see every step of progress along the way, and really keeping close and helping to keep the inspiration going. Very exciting.
Within your Cisco STEM program and your ambassadors, are they all Cisco employees?
They are.
So that's sort of a CSR, a corporate social responsibility policy that you have that allows them to go away and deliver those sorts of things as part of their regular jobs?
Absolutely. So we have a whole bunch of volunteers within the organisation who are trained as STEM ambassadors, and amongst those, obviously, a pretty big bunch of guys who are really excited by Bloodhound as well. So they've been trained separately. We've worked with the Bloodhound team to make sure that they have that in their stack of goodies to take out to schools. So yeah, and that list is growing, and I'm sure after today we're going to get a lot more people kind of wanting to go through and be trained, and the whole STEM and ambassador program for us will inevitably grow more. So yeah, good times.
Well, I'm sure I can speak on behalf of everybody from Bloodhound SSC. We thank you for your continued support with the project, as we do all of our other organisations that are involved as well. We wish you all the best with it, thank you, Terry, for joining us in the studio.
Mark. Thanks.
Well, whilst we have heard from Terry Donovan from Cisco, I think that Jenny Gow has managed to catch up with another very important man involved in the Bloodhound project. She's with Ben Evans.
Yes, absolutely. Now, Ben, you have a lot to do with the aerodynamics, which is one of the key factors with Bloodhound and making it go fast.
Yeah, so I've been working on this car now for over 10 years. I mean, the car is the shape it is today because of all the computer modelling work that we've been doing at Swansea University. Today was the first time I've actually seen the car in the flesh working. It's quite surreal, to be honest. I mean, this car has been on my computer screen for a decade. Today, I got to see it run, and it's a bizarre, surreal experience.
Just tell us when it fired up and started to make its way down that runway. What were your emotions? What were you feeling?
Yeah, do you know what? It was emotional because this has been a theoretical thing for me for a long time. You know, I've been looking at the science behind it, making sure aerodynamically this thing is going to stay on the ground at 1,000 miles an hour. That's basically been my job along with Ron Ayres. Today we saw the car going. You start to believe that we're actually going to do this. This is the first step in a journey towards 1,000 miles an hour.
That's a big question, isn't it? Today it went just over 200 miles an hour, around 208, 210 miles an hour. And the effect that the aerodynamics will have at this speed compared to, you know, multiply that by 5, it is going to be a different effect. So how much can you gain from this?
Yeah, absolutely. This is just the starting point. Aerodynamically, we're just scratching the surface right at the moment. So these low-speed tests are all about, does the car work? Do the systems work? Do the brakes work? The reality is, it's not till we go to South Africa and really start pushing it that from an aerodynamics point of view, we start asking some of the really big questions, which is what happens when it starts generating shockwaves. You know, we've done all the computer modelling. We are confident that this is a safe car to propel Andy to 1,000 miles an hour, but it starts getting really exciting when we take it to South Africa.
I mean, you talk about shockwaves. Can you just tell for people at home or the likes of me what that actually means?
Yeah, so basically, I mean, once anything is travelling faster than the speed of sound, it becomes impossible for the vehicle itself to tell the air ahead of it it's coming. So instead of everything happening nice and smoothly, in an aerodynamic sense, you have these sudden changes in the properties of the air. So a sudden pressurization of the air, and that sudden pressurization is what we call a shockwave. Now, what we've been doing for a decade is trying to predict where these shockwaves are going to form on the vehicle, what they're going to do to the vehicle, and what they're going to do to the surface that the vehicle is running across. Now, we are confident that this is capable of 1,000 miles an hour. Today was the first step towards proving that.
Safety-wise, it's a big thing, isn't it? We've seen a lot of land speed records attempts. To make sure that this stays on the ground, is that the biggest challenge for you guys?
Well, it's probably more complicated than how do you keep it on the ground. The question is, how do you keep the vertical forces on the car within safe enough bounds that it stays on the ground, but you don't drive it into the relatively soft surface we'll be running on at Hackskin Pan. We could end up with the world's fastest plough if we get too much downforce. So actually managing the shock wave so that from 0 to 1,000 miles an hour, from Mach 0 to Mach 1.3, the vertical forces on the car are not going to allow it to lift off, but are not going to press it into the ground. That's the real aerodynamic challenge.
One of the biggest changes that I suppose we'll see with the car that you can predict already is the bodywork, because obviously these tyres, the wheels that are on here, aren't the ones that you'd run when you go to South Africa. They would be different because here it's tarmac surface. It certainly won't be that in South Africa.
Yeah, so we move to solid metal wheels when we go to South Africa, which will allow us to put more bodywork paneling on, particularly around the front wheels. At the back, particularly, in fact, the strongest shock waves that will be acting on the car are at the back wheels of the car. At 1,000 miles an hour, we're predicting that a third of the vehicle's drag will be because of those rear wheels. So we'll be wrapping a fairing around those rear wheels and around the suspension system. So the back of the car is going to change quite a bit between what you've seen today at Newquay and what you'll see next year in South Africa.
And just to come back to today, I mean, it's got to be a pretty special day for you personally when you've seen 10 years of hard work come off so successfully. But when you go to bed tonight, will you be thinking about what's happened today or already thinking about the next thing?
I think when I go to bed tonight, I'm going to be so tired I will go straight to sleep. But yeah, no, I mean, I'm thinking about the next step. I mean, I want to see this car go faster. You know, this car is capable of 1,000 miles an hour. I believe that. We've scratched the surface today. It's ticked all the boxes it needed to tick. And it's just given us confidence that, you know, we can take the next step now.
Well, congratulations for all your hard work, the hours that you've poured into this, and for it to be so successful today.
Oh, thank you very much. Thank you.
So from here, let's cross back over to you in the studio because, I mean, the atmosphere is still absolutely buzzing.
Okay. Well, great to hear some more reaction. And Ben Evans, who was out surfing, would you believe, in the Cornwall seas earlier on to understand fluid dynamics and how water moves around the surfboard compared to air moving around the car, as we've just seen from Bloodhound. Now, somebody who knows a lot about speeds and is here to understand and help us appreciate some of the things that have been going on out there is Ollie Marriage from Top Gear magazine. So welcome along, Ollie. You might just need your microphone just a little bit closer to your chin and we'll be fine with that. Now, it's great to see you along here. I know from what we were just discussing off microphone, you had a sneaky look at the car run a couple of weeks ago, so you're not a newbie today, but you're still wowed.
I am completely, actually. It's so good. I just said, you take away a snapshot of the car going straight past you with the cones of flame out the back, and it just looks so special, so spectacular, and so unlike anything else you see.
You get to drive all of the latest Ferraris and McLarens, and I'm hugely jealous, and all of those other things whilst we're going on, as your day job. And so the obvious question is, for you, with all of that sort of experience in your regular working environment, how does Bloodhound SSC compare? Because I think you've done that comparison recently.
I have. I think last time I came down here, I spoke to the engineers and I said, I just want to know how fast it goes. I want to know what the acceleration figures are. So they gave me this enormously complicated printout of all the stats for the G-force acceleration and the time against distance and the speeds achieved. And so I did a story comparing to how it compares to a McLaren 720, which is one of the fastest road cars we've ever tested. And that did 0 to 60 in 2.7 seconds and 100 miles an hour in 5.3. And we thought that was astonishing. And up to about 50 or 60 miles an hour, there's not a lot of difference between them, actually. The McLaren's actually ahead until 50, 60 miles an hour. But it's then, of course, a road car starts feeling the effects of aerodynamics and everything else and starts slowing down quite considerably. And, of course, at that speed, Bloodhound is only just getting into its stride. So the fact I really liked is that it took the McLaren 8-point-something seconds to do 50 miles an hour to 150 miles an hour. And that's a very, very, very fast car. Bloodhound did it in 3.1, and it's that 1.5 G acceleration. You're piling on 30 miles an hour every second the car's running, and that's just devastatingly fast. And then you think it's going to carry on doing that all the way to 1,000 miles an hour.
Well, it's that acceleration curve, you know. There is some data on the Bloodhound SSC website that sort of shows you what the acceleration and deceleration looks like, because they're not nice smooth curves, are they? Because our car, unlike a road car where you accelerate and it's a fairly linear, straightforward acceleration curve, because we're using jet engines, which will then have afterburner rocket motors with stage 1 and stage 2 ignition when we run the car fully. And our acceleration is continuous, as you say.
Well, exactly, and I think I'm amazed when anything has 600, 700 horsepower, and I think this is frightening. And then you realise that the jet engine alone out there has the equivalent of 58,000 horsepower, and then when it's running fully, it'll be about 135,000 equivalent horsepower. And you're thinking, that is just balmy.
And that's to power one man.
Just one man.
Just one man. The QE2 had almost the same amount of brake horsepower. And think how many people were on that as it was trying to get through the seas. You've now seen the car run. You were here for the test a few weeks ago. So, did it meet your expectations? Did it do what you thought it would do? Were you?
Actually, it did way more than I thought it could do, and I hope everyone else can appreciate what surprised me most about it. I've known Mark Chapman and the guys for about 9 or 10 years now, and through all of that I remember talking to them and saying, well, we're not going to be very fast up to 100 miles an hour. We'll be getting 15 seconds to get to 100 miles an hour. And I came down here and watched it for the first time.
I think we can see some of the replays now, Mark.
And it's just how fast it goes off the line, how quickly the afterburner lights, and then how fast it disappears down the runway, and then how quickly you end up shutting down the afterburner, and of course it's still accelerating, still pushing through.
That was something that I picked up on when I was talking to Andy a couple of days ago, and here's another angle where we can look at that run. Is that he shuts off at 130 miles per hour, but by the time the signal has gone from where he is back to the jet engine to do what he wants it to do, the car has then reached 200 miles an hour, and that's staggering, considering how quick that response is.
Yeah, and I wonder how terrifying that would be for a mere ordinary mortal when you come off the throttle and nothing happens. It just keeps accelerating for another 70 miles an hour, right up to the point, and you've probably got your feet on the brakes and you're thinking it's still not slowing down. It must be quite alarming unless you're used to flying fighter jets for the RAF in your day job.
Very disconcerting, I would have thought. And I suppose that the flip side of that is that he's got the same issue at the bottom end of the run, because he's running carbon fibre discs.
Yeah.
He won't have been able to do a warming up lap to get some temperature in them, as we see in Formula One. Yeah. So he's then, as you will well know, with the cars that you drive, which will have ceramic carbon discs and things like that, you've got to get the temperatures into those discs to get them to work properly, and he's not able to do that in this. So he puts his foot on the brake, and it takes a while again.
Yeah, exactly. So I understand from the engineers that one of the problems Andy was having initially was he wasn't getting the brake temperature in, because he hadn't quite appreciated how hard he needed to press the brakes early on. And the engineers came in and said, no, just stamp on them. You've got to get heat into them. You've got to get that retardation through the brakes.
So when we look through at the runs, I was quite surprised when we get to the sort of the middle part of the runway, really. So he's running down runway 12, and half the way along runway 12, there's where he did the figure of 8. There's an access road which he had to cross to get from one side of the runway for the other. And when you see the suspension movement on that car, I was quite surprised how much it moved, considering it's a 5-ton car.
Exactly, and I think I'm seeing from the engineers saying they're running it surprisingly soft, and they were surprised how much and movement and compression they've actually engineered into the suspension.
And that has to cope with enormous forces. When you think of, I suppose, a normal road car with the aerodynamics that are flowing over that, then we largely look on road cars to create a car which has fairly neutral handling, but it gives you confidence in the corners with a reasonable amount of aerodynamic and mechanical grip, whereas in stark contrast, we want to go quickly. The one thing we don't want is any drag at all, because that will slow the car down. So we don't want that aerodynamic grip because we're going in a straight line. But the flip side is we certainly don't want any uplift as well. So it's whilst the engineering, some of it's transferable from the road car, other bits are totally alien.
Exactly, and that's interesting. And I think it's on the whole, you look at Bloodhound, you can't see any relevance to road cars in it. But what I do like is the fact that they have thought about some of those projects, and I like the fact that initially they had the Jaguar V8 in there as the fuel pump, just to pump the rocket fuel into the hybrid rocket. And now they're talking about, the announcement today, of course, was that they're going to replace that probably with an electric motor, which actually has benefits because it allows them to place the battery packs elsewhere around the car to power the pump, to drive the motor, the rocket fuel through.
Well, again, I think the honesty of the project has always been is that as and when new technologies appear, we will consider if that is more appropriate to incorporate in the car. And I think the announcement, as you alluded to this morning, is that they are going to look and see. There's no confirmation, but they're going to look and see whether battery technology has now reached the point in that we could put an electric motor in to power that fuel pump. And as Mark Chapman referred to, this is a rolling laboratory. Every time the car goes out, we learn something more about it, and it's been, as Ron Eyre suggested, 11 years since they first spoke about it to where we are today, and technology moves on, so you've got to be open-minded.
Exactly, and I think that's really good, is that you can see this as a team at the cutting edge. They're doing, it's live engineering, and that's what's lovely. They know there's no rivalry, it's not like Formula One where there's secrecy involved, and they're very tentative about how they deal with everything. For Bloodhound, they can be open, they can be as transparent as you like and tell you this information, because there's no secrecy involved, because there's no one else out there doing anything like this.
I could absolutely watch that all day, and I'm sure that is going viral at the moment. Hashtag Bloodhound is go, hashtag Bloodhound is go is what you need to be tweeting, because we want everybody in the world to know about this. And we even know now, of course, we've got 4G in the hack scheme pan as well, which is part of the legacy of this project. You've followed the project for a long period of time. Is there anything with your involvement with the engineers, or now your knowledge with the car as that's built up, that's just really blown your socks off?
I think there's so many little details. That's what I love about it. I love things like they found when the Thrust SSC ran that they had the temperatures at the wheel rim got so hot, and from the G-force involved, that they'd actually get stones embedded in the wheel, and then how they're going to deal with that this time at hack scheme. And there's all those details, and like how how they're making the EJ200 engine, which is obviously only designed as an aero engine, how the complications they've had to go through to make it run in a car when all it wants to do is think it's in an aeroplane. Absolutely. So it's astonishing. The engineering, all those little details are just fabulous.
Well, of course, it's designed, that EJ200, to work with nice thin air, not the soupy stuff that we have down here where we all live. If the call came, would you?
Oh, I would love just to sit in there and just open the throttles a little bit, just to do a little bit. I think anyone here wouldn't they?
Absolutely, I'm there with you.
It would be astonishing to have that opportunity.
Just to sit in it would be.
Yeah. Absolutely.
I saw there was one of the cameras wandering around earlier on, and there was an engineer in there, clearly working, doing some bits, but he was sat in the seat. Yeah. Oh wow, was I? Yeah. I've been jealous. I'm jealous of your job. I'm jealous of his job.
It's knowing that that seat has been designed around Andy Green, and the steering wheel is 3D printed to Andy's hand shape, and all of that sort of thing. It's just a lovely, lovely touch.
I can tell you're as enthusiastic and as big a anorak as I am about the whole thing. And I think maybe just one final question is that we've seen numerous new technologies find their way into probably initially hypercars, then into supercars, and ultimately into the road cars that we all drive today. Yeah. Do you think that there will be some of this technology that's coming out of Bloodhound that will find their way into the road cars of the future?
I think it'll be very, very interesting. It's difficult to say for sure. Yeah. I think if they can get the electric motor to work, then I think that has relevance to road cars, and it's always very interesting if they're giving this engineering a very high stress environment, looking at where that can ultimately lead to for road cars has great potential.
Well, thank you very much, Charlie Marriage, for joining us in the studio. Delighted to see you here. And I've gathered that Jenny Gow has managed to catch up with somebody else. She's caught up with somebody from Oracle. It's time to chat to Chris and Jenny Gow.
Yes, I've got Chris and Caroline down here from Oracle, and we've just been having a good old gossip actually about what it's like to work on this project and the more human side of things really, which is that kids, children, friends, family, everybody can get involved with this. And Chris, you said you've got 2 kids that have been following this quite closely.
Absolutely, yeah. Well, I've got three children actually. My 2 boys, Charlie and Ali, they're sort of 8 and 6, and they're obsessed with this. Charlie definitely wants to be the next Bloodhound driver, and he's been inventing new cars that could go potentially even faster. So he's really enthusiastic about this. It's a great project.
I love that. Now, just tell me what Oracle's involvement with the project is.
Yeah. So we are collecting the data off of the 550 sensors across the car. We're providing them to the engineers so that they can do some analysis and see what's going at every step of the way. And we're also providing that to STEM. So that's provided out to live, to the education across the world, actually.
And education is such a big part of this project. We keep reiterating it's not just about going fast. That's kind of the added bonus you get with it. But you know, the education zone here is full of activities that people can get involved in, and it's about sharing this experience as we go through from, you know, starting out to 200 miles an hour today to, you know, the final runs in South Africa. And there's a lot of valuable information that you can share.
Totally. So when you go into the Bristol HQ where they're building the car, the #1 aim for this is to increase STEM, to inspire a generation, and to go 1,000 miles an hour in those 3 orders. And it's just humbling that we can help with Oracle provide this data. And when we've created the solution, when Chris and Asaf have created the solution, we've kept that in mind. So actually, inside the car is 3 or 4 Raspberry Pis. There's a microbit in there. So literally, you could go down to any high street hardware store and you could buy this stuff, and you could recreate the data solution that the Bloodhound data is being pulled from. And then obviously that goes into the Oracle Cloud to analyze.
Now, Chris, when it comes to data in here, I mean, in real terms, for the layman on the street, how much data is coming back? What can you see? I mean, what's being analysed?
Yeah, well, it's quite amazing. There's over 500 sensors on this car, and you know, some of these are sending out, you know, many readings a second, 50 or so readings a second, and it just allows us to look at a variety of perspectives. So you can see the acceleration that's being experienced by Andy when he's in the cockpit. I think the maximum values on that were around like 1.4 Gs, so it's more than 1.5, or around about 1.5 his body weight pushing back on the power of that engine. And we can see what's happening with the brakes. There's massive high temperatures coming through when it's slowing down. Obviously, the speed is the key thing everyone's interested in, but there's so many other sensors that we can learn from, and we can look at all the correlations and what happens. You know, we're noticing dips in the runways based on different stress and strain levels in the push rods, on the suspension, on the strain gauges attached to the jet as well. So there's you know, the idea is we get that data out there. We provide some of it. We provide some views that help people look at it, and you know, you can take it yourself and you can have a look and see what you think you can find based on that, and see what we can learn.
Was that important to you guys to have this very interactive format of data that other people can utilise?
Totally. So that was the aim and the ambitions of Bloodhound, was to have live data being pushed out to the world, so kids anywhere can just download it and manipulate the data and play with the data themselves. And that was a real key thing for Oracle when we came on board.
Now, just tell me, the other thing, I don't know if Mark the cameraman can just angle up to look at the wing, but the wing is one of the important factors of this because it's enabled people to actually sponsor it and get involved. And someone contacted me yesterday saying, oh yeah, I'm on there, look for me. And I was earlier, I said, oh, it's quite difficult to look for you. I might be there a while, but Oracle have simplified that, haven't they?
We have. So we got involved at a data level, and then we actually got involved at a customer experience level as well. So one of the main feedbacks was that people couldn't find their name on the fin because there's about 25,000 names up there. So we have created a search engine where you can just search for your name and it will locate your name on the fin.
Amazing. That makes it a very easy experience, doesn't it? So going forward, Oracle's involvement with the project and your keenness to see it work.
Yeah, absolutely. I mean, this is just a great, exciting project to be involved in. I certainly want to carry on taking it further. We'd love to see the car going even faster. I'm sure we will see the car going a lot faster even next year as well. So definitely, yeah.
Can I ask a stupid question? The faster the car goes, does that give you more and more data?
You start to learn more. Every time you reach, you know, a new threshold, you start to understand what happens to the other parts of the car as you're breaching each of those thresholds. You know, they're not going to go and do 1,000 miles an hour straight away. They want to learn. They're going to develop from that. So yeah, absolutely. Every time they get to run it, each time is more data. Each time gives us more opportunity to learn. And the faster they go, you know, they can see what happens in different parts of the car and make sure that Andy's safe at the end of the day, which is, you know, got to be a key objective as well.
Obviously, there's a lot of data online on the website that people can look at, but if they want to get involved here while they're in Newquay and at the airport, there are some ways that they can interact, aren't they?
There are. So we have a mobile web interface that you can look up. It's on the Bloodhound website, or you can follow any of the Oracle social media, and it's on there. And you can look at Andy's live dashboards, and you can look at all of the previous runs, data, videos, everything.
And virtual reality is a key way forward at the moment, and I've been told that if I go over in that direction, I might be able to put on a set of goggles and get a little bit up close and personal with Andy.
Absolutely. So if you go to the Oracle stand, we have a VR experience where I was completely excited when this little 6-year-old put them on this morning, and his face when he saw that he was in the cockpit with Andy Green, and you can literally do a 360, you can look around and you can travel with Andy on one of his runs.
So cool. Chris, Caroline, thank you so much for talking to us and sparing the time, and I hope you enjoy the rest of the journey with Bloodhound as Oracle.
Absolutely, thank you very much.
Thank you for having us.
So these guys are now ambassadors, they're going around to schools, they're doing all sorts of talks to try and embrace Bloodhounds and Oracle's association with that. And I tell you what, Mark, the sun's coming out.
Sun's coming out, which means scarf off, shades on for Jenny Gow as well. And yeah, that's the Bloodhound effect. What we're seeing and what we're hearing is that Bloodhound effect as it begins to spread, and that's what we want. Hashtag Bloodhound is go. Well, we've heard from a couple of our supporters. Another one has come to join us in the studio as well now, and it's Kedar Panya, who is the Assistant Director of Business Engagement for EPSRC, that has come to join us. So thank you for taking the time out of your day to come and join us. First of all, I think, we're talking about the Bloodhound effect. I think you've got the Bloodhound effect, haven't you? Looking at the smile on your face, you've enjoyed yourself already.
Well, what a phenomenal day! No, absolutely. I work for EPSRC, said one of the research councils, and we have the privilege of funding research across the country. But really, to come here and see British engineering in action is, phenomenal. Really phenomenal.
Just tell us about your as a business, your involvement in the project and what you've done and what you're looking in terms of the ethos of the project and why that matches your business.
Yeah, so as a research council, we fund long-term research with impact, and so British universities are some of the leading universities in the world really to do engineering, and so our role was really to fund the Swansea Group and to do the aerodynamics.
That computational fluid dynamics that was all done, all those big number crunches.
All the CFD, we've supported that, but we've also more recently supported the education programme. So we've had a role there in providing support for the groups to go out into the schools and to engage school children. And then over the long term, obviously, what we're wanting to do, we're very keen to build the skills and the talent that UK engineering needs. And something like this, is an iconic programme like this, has a real impact for the long term.
Well, I think UK engineering, but also you look at globally. It may well be that it's an American-owned company that's got a base in the UK. But if you delve that little bit deeper, it's largely the English people that are at the high levels of that engineering and medical science and pushing those boundaries. We can see that skills gap still looming, can't we, in the future?
Absolutely, yes. There is. All the projections show that there is a skills gap unless we are able to do something about it. So this sort of work really does, in a real way, it leads to new knowledge, new understanding, but it also then starts to build around it a kind of an ecosystem of public awareness of the importance of engineering and science. And then there are translational benefits that go out of, you mentioned CFD in cars, but you think about transplant airflow and think about blood flow in the body, the same fundamental principles of fluid dynamics apply there. So, in a sense, this work could lead to lots of spin-outs and lots of other benefits in areas that you might not envisage at the start.
Are you already seeing some tangible results as a result of your involvement, your direct involvement in the project?
Well, it's difficult for me to comment on directly. I know the research groups are saying there are lots of interesting outcomes. It's not just CFD, but in terms of lightweighting materials design. You think about where this might go. So this is Bloodhound, an iconic vehicle. But across the automotive sector, if we could get more streamlined designed cars, that will help in fuel efficiency in years to come. We're trying to move to a low carbon economy. So in a sense, all of these things are interlinked.
It's very difficult to compartmentalize them. They all have an effect on one another. The car today, I'm guessing, as with many people, it's the first chance you've had to see the car run. I'm not sure whether you've had the opportunity to see it whilst it was in build at the factory, but it would be a difficult person to go away from here today and not have been impressed with what we've seen standing still, let alone when the car was heading down the runway. Oh
yes, no, absolutely. When I had the privilege to actually go on the inside and get a few photos taken quite close to the car, but I wasn't that old, I'm not that old, so I don't remember the moon landing, but I kind of feel this has the same aura to it, you know, the moon landing, the Apollo programs, and what followed in terms of the real enthusiasm that came with those sorts of programs. And I feel, you know, I feel proud. It's a British, it's done here in the UK, as you said, obviously with global impact, and I kind of feel that this could have the same effect as the moonshots did all those years ago.
Well, I think, you know, looking at the information that we've been receiving whilst we've been on air since 10 o'clock this morning, we've been broadcasting locally, but of course we started streaming to the world at around about 12:30 UK time. You know, we are seeing already some fantastic feedback coming through, and people doing what, you know, the generation that we're trying to focus on it are engaging, and they're engaging in the way that they know best, which is social media nowadays, and to be able to quantify it with social media hits and tweets and everything else, you know, that's quite a strong message, isn't it? That I assume as an organisation satisfies you that you are focusing your resources in the right area.
That we are, yes, that we are, and that the research that we fund and the researchers that we fund are accessible, that science and engineering technology is fun, as well as it having real impact globally, and those are some of the key messages that a project like Bloodhound enables us to put across.
What do you see sort of moving forward for your organisations and your relationship with Bloodhound as we head towards 2018, where we know the car is going to be going for very fast runs, speeds, as we say, as yet to be confirmed, locations yet to be included, so confirmed. So there's some exciting times ahead.
There are some exciting times ahead, yes, and I think the research programs are still ongoing. And our primary interest from an EPSRC point of view is the investment in the long-term research. So that research is ongoing. Still a number of questions I'm sure will arise from the run today that will need to be looked at, and people need to build on that as we go forward.
And again, that's where some of those people that you've had that relationship in terms of the funding, you mentioned Swansea University, and there are other universities involved in this project as well, the likes of the University of the West of England, but that's where, again, there may well be, as a result of this live data, because this is not a demo run, as we said, this is live test run, some of that data may be fed back through to Swansea, so there might be more work to do on the computerised fluid dynamics, potentially.
Indeed, and there might be new, you know, every piece of research in its own right then leads to new avenues, new ways of thinking, new questions that arise that need to be addressed, and absolutely, I'm sure that will be the case here as well.
Well, thank you, Kedar Panya, for your time. Thank you for your support as well of the project, and we wish EPSRC all the best in the future as well. We've got another video that we just want to show you, and we want to look back at what happened 20 years ago, 15th of October 1997, when Thrust SSC went supersonic.
At the wind at measured mile, 10 o'clock, light and variable.
Variable, love it. Full video Wednesday morning, 15th of October. 9 o'clock in the morning, it's about 3 to 4 degrees outside. We're looking for a flat-out run through the measured mile, trying to get a supersonic two-way average today.
It's a popular misconception that driving a land speed record in a straight line is about anchoring the steering wheel, planting your foot to the floor, and just waiting till you run out of fuel. If only it were that simple. The car moves around an awful lot. Any road car moves around a little bit, and it moves around more so as you go faster. When you go a lot faster, like 700 miles an hour faster, the car moves around a huge amount. The wheels are now skimming across the surface, the shock waves are generating uneven forces, gusts of crosswind, the car is sliding all over the track. In terms of doing a run in Thrust SSC, big intakes very close to the ground, I'd put very little power on to start with to accelerate the car without sucking lumps of desert into the intakes. So initially just inching the throttle forward, letting the car roll slowly, progressively, around about 80% RPM on the engine, that's quite a low power setting, just letting the car accelerate no faster than a normal family saloon car would, pulling away from the lights.
SSC ready to roll.
SSC with fast chase rolling, you are clear supersonic.
Clear supersonic, SSC is rolling.
Rolling up through 10, 20, 30, all the way up through 50, 60 miles an hour. The reheat nozzles at the back of the engine start to close down to increase the thrust output. Now accelerating more quickly through 90, 100 miles an hour. Now got really strong airflow into the engines. Now I can spin them up very quickly. Ease the throttle forward to the dry stop. The turbines spin up to maximum speed. They are now working flat out. To get more thrust, neat fuel goes into the exhaust and literally reheats the exhaust. Reheat. Check that both needles are showing a light up so that both light together. If one lights and the other doesn't, the car's going to want to go in a circle, which is not good at supersonic speeds. Having got both lit, ease my foot all the way down, both nozzles open fully, we get absolute full power and the car is now accelerating at something like 25 miles an hour every second. 250, 275, 300, 325, and it just keeps going at that speed, up to 500, up to 550, approaching 600 miles an hour. The airflow starts to go supersonic underneath the car, which affects the handling. It goes supersonic over the top of the car.
700, just about in control, on the wrong line, don't worry about it.
It's the loudest, highest pitched scream I've ever heard. The car tended to pull, because of the way it was constructed and the staggered rear wheels, tended to pull hard left at around 600 miles an hour, and that was requiring up to 90 degrees of steering lock to keep it straight. And on our first supersonic record run, it was such a hard pull, I actually had to throttle back to minimum reheat and close the reheat nozzles right down to reduce the thrust, rebalance the car. The car is now 50 feet offline, and I'm steering it effectively on the throttle at 650 miles an hour. As the car starts to respond, as soon as it starts to come back towards the line, I've got to put full power on or we won't get supersonic. And as it comes back to the line, take the opposite lock off, straighten the car back up. Now it's going supersonic. At over 700 miles an hour, all the airflow settles down, starts to go fully supersonic, and it runs absolutely as straight as a die.
700, just about in control, on the wrong line, don't worry about it. 730, it's a good here, goodie. Looking for express, flickering. Looking at the end of measured mile. Burners are still good. Excellent.
Through the timing lights, which took 4.5 seconds, about 4.7 seconds to cover the mile through the timing lights. Unbeknown to me, we're also throwing a huge sonic boom out across the desert. My job is still only half done. I now need to stop the car at the other end of the track. So throttling back at the end of the measured mile, we've now got warning captions for all of the oil thrown towards the front of the engines because it's slowing down so quickly. The low fuel caption is flickering. The car is now slowing down at over 1G, over 20 miles an hour per second, but very rapidly as the car gets subsonic. We've got a 10-ton car, very slippery 10-ton car, still hammering along at over 500 miles an hour. I'm waiting until the distance at the end, to the end of the track equals the speed I'm going, which is also changing. When the two numbers match, punch out the parachute with a button on the left-hand steering wheel yoke, and immediately parachute goes out, generates another 4 or 5 tons of drag, and bumps the deceleration back up to 20 miles an hour per second.
450, shoot one. Yes, we got it. Everything is going to be wonderful.
The car is now going to slow down, and I'm still checking the numbers, slowing down through 400, 350, 300 miles an hour. There's about 2 miles left to run, 250 miles an hour, 200 miles an hour, we've got a mile left to run. I'm now going to shut the engines down. They've had a few seconds to cool. We don't want to ingest anything else. So shut the engines down, start to ease on the wheel brakes. I'm now looking about half a mile ahead, looking at the recovery crew, so that as we roll to a stop, I ease the brakes on and we stop exactly 14 miles from where we set off, right next to the guys. So you've got to turn a 10-ton jet car around, put the best part of a ton of fuel in, reload the parachutes, do a full systems and data check, and confirm it's safe to go back through the measured mile within 1 hour. So stopping in the right place is the key bit to starting the pit stop on the fastest car in the world.
SSC, the car is stopped, mile 13.5.
SSC copied. Assist all stations standby. SSC has stopped, mile 13.5. SSC has stopped.
The drive then involves repeating all of that and subsequently stopping the car at the other end and waiting for the timekeeper to have recorded it. 15th of October 1997, he came back with those famous words, "Pit station, this is USAC timing, I have some times for you." And they were supersonic, and that record still stands today. The rest of the bolts have just arrived, obviously.
Great insight by Andy Green into what happened at Black Rock, Nevada 20 years ago on the 15th of October 1997, breaking the land speed record that had been set by his predecessor, Richard Noble, Project Director of Bloodhound SSC. And we've got another member of the Bloodhound SSC team that's now come to join us in the studio. We've got Stuart Edmondson, who is a very important man, head of engineering operation for the project and the man in charge, really, of the test programme here at Newquay Airport. So welcome along, Stuart. I'm sure it's been an enormously busy day for you, albeit I suspect a hugely satisfying one, because the car looked great. Is that job done?
It's not a job done, but what a big day. This has been such a wonderful experience. The whole team are buzzing. We've spent years designing, years building, and then the last few weeks testing, and today has been such a success. But no, it's not all over. This is the beginning. This is a big milestone in the trials and testing that we have to do, and we've got a lot more to do.
So I suppose all of that hard work done, looking forward, even more hard work to do. Does the difficult bit come now? Is that where it now starts, this next phase?
I would argue this is a big milestone in the testing of the car. It's the first time it's run. We've learned a lot about integrating the systems on the car, and obviously we've integrated the EJ200 engine. So that whole process of learning of integration and the integration of the engine has put us now in a good position for the integration of the rocket and all the further tests we need to do at higher speeds, which unfortunately we can't do here at Newquay.
Just to sort of bring it to life for people as well that are perhaps not on site here but looking on the web stream, just tell us about the background that you've come from and how you became involved in the project.
Right, my background, engineering, university, and I joined the Air Force. I was inspired about fast jets, and I ended up doing 19 years in the Air Force on fast jets, initially on Tornado, but then on Typhoons, and the link obviously with Bloodhound is the Typhoon engine. I got involved with Bloodhound when I was still in the Air Force, and then last year I got the invite to join the team, and what a privilege. And all the hard work the team's done over the years has now paid off today, and it's a wonderful feeling.
It gives you a very warm, fuzzy feeling, doesn't it?
Oh, yes. It does. I mean, you chat to the team. I mean, the focus out there is the car and Andy, but the guys, every single, all the guys and girls that are involved on the team, the engineering team, are absolutely buzzing. You should just hear the discussions. They've gone through some pain, and today it's all just bubbled to the surface, and we're just so pleased that today's been such a success.
I think the one thing that I've certainly not mentioned it today, and therefore there'll be a lot of people that aren't aware, that to even get to today from where you were 3 or 4 months ago, this date was set. And the team then had to make sure that everything was done. For the first time, you'd had the car put together, but you then had to take it apart again to check certain components, which means you then have to rebuild the thing back up again. So the pressure was on to even achieve what we've achieved today.
Indeed. I mean, the date was set. The date was set, and we had to work to that date. And we came across technical problems, but we solved them. And the teamwork has been key. The teamwork has just come together, which is part of the learning curve we need to go down in terms of being ready for South Africa, because ultimately you've seen a run today, you've seen all the effort in getting the car running today, but for the record we've got to do that run twice and turn the car, refuel, rocket fuel, the works, and that's all going to be based upon the teamwork. And so the last few weeks as the start of the journey is operating as a team to support this car and get the 2 runs required to break the land speed record within 1 hour.
You mentioned the running of the car in South Africa, so I think now is the perfect point so that we can have a quick look at the video where you tested the wheels on the very surface on which Bloodhound will run.
So with a land speed record car, it's very key to get the wheel just right. So the cars you see running here on Kalahari Speed Week and the Bonneville Speed Trials, they run rubber tyres. The reason they do that is they've got driven wheels, so their engines are driving the wheels, they need traction. Rubber's excellent for that. Around about 400 miles an hour, as the wheels go around faster and faster, the tyre peels off the rims and it comes off. So you then have to go to a solid wheel. So we've chosen aluminium, and basically these trials to verify not only the material we've got, but it's that final bit of the profile. So whether it digs into the desert or whether it's very smooth, and it's very key. This surface is unique, and it is. Andy Green's looked at an awful lot of places, and this is the one place on the world that will become the world's best place for breaking land speed records.
And action.
Right, the main objective is we're trying 2 new wheel profile shapes on the pan here. We came out in November last year to do our first testing out here, and it became very clear that the wheels we were using were cutting through the thin mud layer on the top of the surface and running on the hard kind of bedrock that's below the kind of mud you get on the top. And we were seeing quite a lot of damage to the wheel as it was running on the surface. So we've got 2 new wheel profiles here today that are flatter. So the idea is to try and get them to run on the mud surface and not run so deeply sort of embedded in the ground. If they run too shallow though, then we'll lose any kind of lateral grip because they have to dig in a little bit to get some kind of grip. To start with, we're going to just run the trailer down the desert for a couple of kilometres and then add some more water ballast to the tanks, and then we'll work our way up to the full car weight, and then we can monitor how far the wheels go into the dirt as we increase the weight. And then what we'll also do is we'll drive the lorry in some circles, and if we know the speed of the lorry and the radius that we're going around, we can work out how much lateral grip we've got. And by looking at the indents into the mud, you can see how much the trailer wheels are actually sliding. And from that, we'll get a pretty good understanding of the lateral grip as well. So that's the plan anyway.
It's been really good. I mean, today we ran the trailer with the heaviest weight, so it's now pretty much what the car will weigh on one axle. The straight line tests, basically the flatter wheel is running to its full width, so it's getting some lateral grip, but there's a concern that it's kind of digging in at the edges. The V-shaped wheel hasn't broken through the surface at all. It's been showing really good stuff. It's not been damaged at all by any rocks that are in the surface. And we've just done the circle tests either way. And fair play, it's been pretty impressive. The trailer has just started to move in both directions, and yeah, it's showing that we're getting fantastic grip, so I think it's been really successful.
Yeah, I mean, it's excellent. I mean, it's really interesting looking at how the 2 wheels behave differently. We obviously made them very different, so we could definitely see a difference. And now we've got the previous data we had that we collected in November and the data from these 2 wheels. So from this, we'll be able to design the optimum profile, should I say, for the wheels for the first year. And then when we start running the car, obviously we'll learn an awful lot more about how the wheels are behaving with the real car. But this is the first major sort of hurdle you've got to get over into designing an actual profile.
We've had a quick look then at the testing of those wheels out on the hack skiing pan, and vital that those wheels were tested when you look at what happened there in the VT that we've just seen. Stuart Edmondson still continues with us in the studio, who is the head of engineering operations for Bloodhound SSC. The wheels are an important thing. Stopping is an important thing. We know that for sure from 1,000 miles per hour back down to 0. But where Andy stops is pretty vital, and that's where the record could be won or lost.
It can indeed. So we've got to do 2 runs through the flying mile, measured the average of those 2, but the key point is we've got to get back through that 2nd mile within the hour.
So you've got a 13-mile track, 5.5 miles to accelerate. The important part is the middle bit, that measured mile, so that's where you break or don't break the record. 5.5 miles to decelerate. And when does the clock start ticking? When you start that run, or when you first enter the measured mile, or when you stop the car?
Entering the measured mile.
Entering the measured mile. So that's when the clock's So you don't get an hour then in reality. By the time a car has stopped, you don't get an hour to do what you need to do.
You don't, and hence you've alluded to it, it's stopping the car in the right place, and Thrust did nail this in getting the car to stop where the turnaround team are. And so critical for us is every second counts. So if we can stop the car safely at the right location, we minimize the time it takes for the turnaround team to get to the car. Once we get to the car, it's got a whole load of heat energy within it. We've got to dump that heat energy in the form of water, replace that with cooler water in our 2 cooling systems. We've also got to replenish the jet engine, so jet fuel. We've also got to replenish the rocket, so there's rocket fuel. All of that has to be done in a timely fashion to, as you point out, start the car up, get Andy back in it, start it up, do all of the system checks, then release him, then he's got to accelerate back up to the flying mile and get back into it within the hour, and that is absolutely crucial. And
so the one thing you don't want then is Andy, and that's where it's so critical. The acceleration part of it is critical, so it hits peak speed at the right point of the circuit, but equally as critical, if not more critical, is the deceleration back from that terminal speed, which is going to be in the region of 1,050 as a peak speed that you're aiming for. Because if he ends up 100 metres away from the catch crew, how much longer is that adding to that turnaround for you? By the time you've moved, how many vehicles to get to him?
Yeah, well, the exact number of vehicles we haven't fully assessed. So part of what we've been doing at Newquay is starting to assess all of the procedures and the various roles and functions and how long they take. That's all been done through the trials here at Newquay. So this is not about firing the car down Newquay Run and testing it. It's not just that. It's understanding how long it will take us to do the various functions. I'm then going to use that data to formulate the most efficient plan to conduct all those things that I mentioned previously. So moving the vehicles, how many are there, the speeds those vehicles can travel at, will all have to be taken into account. And ultimately, we can't afford to miss a record for the fact that the turnaround didn't turn the car in time.
That happened, did it not, with Thrust SSC? There was one run, I gather, where the car came to a halt in the right place, but by the time the car had been serviced and turned around and got back into the measured mile, you were a matter of seconds outside of that 60-minute barrier, and that would have broken the record, but it didn't count and will never be registered because you were too late.
That's my understanding. Now, I didn't have the privilege of being there, but that's what I've heard, and that is it. I mean, this is all about the car, but it's all about the people, and it's all about the processes to get a record, and we're beginning to learn on that journey with this team, with Bloodhound.
And I suppose that's no different to something that we would see in Formula One in a pit stops, where you practice the efficiency, you make that process of servicing the car, doing what you need to do to it, which is entirely different to a Formula One team, but whereas they do it in 3 seconds, you've got a bit more work to do.
But there's a key difference, that they do this regularly, and that's why Newquay is so important to us. The opportunities for getting this right are limited, so we have to make the most of that. We are not doing this day in, day out. I wish I could run Bloodhound every single day. I can't. But when we do run it, we're exactly focusing on those processes. And when we go to the desert, as we increment the speed, again, that's an opportunity to finesse those processes.
And do you, throughout those processes, and as you finesse that process and increase those speeds, does that mean that in that turnaround period, as the speeds get faster, there must be more work for you to do because you'll be checking other bits that may possibly have a bit more fatigue as you start to go into quicker speeds?
Yeah, the key thing is when we're incrementing the speed, a lot of the trial runs aren't for the record, so we can stop, pause, learn and discuss things. So as we increment the speed, we're testing the car and we're also testing those turnaround procedures, but not under the pressure of doing a turn. As we get closer to going for a record, we will then do some live dress rehearsals of that. So the good thing, again, just as we've done in Newquay, it's a slow pace and we learn a lot from that, and we're going to build that as the speed of the car builds.
You mentioned earlier on sort of the excitement, the enthusiasm of what we've achieved today. Now your guys must be, without question, running on adrenaline at the moment. You know, they've got to repeat this again. You've got well, I say a down day tomorrow. You haven't. You'll be busy. I know that. This is the Bloodhound project after all. But they must be running on enthusiasm, and that's not a bad thing. The fact that they've going to have a long day today, they've got to service the car tomorrow. We'll do it all again on Saturday, because that again is in itself testing and training for what are going to be very difficult conditions in South Africa.
Absolutely, and this car, we could run this car again today because the design and build of it is such that it could do that, and that's phenomenal. We've got a car now that is got serviceability is right up there. Now, you're right, Saturday is again all about resetting and going again. Again, a great opportunity to perfect and just finesse, I've used that word before, how we operate and run the car. And for me, what I'd like to point out, for me, the big day is Monday. Monday is when I was a kid and I saw fast jets. For 3,000 children on Monday, this is going to be such a day for them, and I can't wait to see their faces. I present at schools and see their faces, but when they see this car run, it's going to be phenomenal. And ultimately, one of the aim of our car is the inspiration next generation, and I just hope they come away from that going, wow, that is amazing.
Well, I think they will. The running of the car, we'll have our Bloodhound education team doing science shows up on stage, and I gather they're going to sort of do something that also gives us some sonic booms as well. And I think somebody that's already in the education area and therefore enjoying all of that is Jenny Gow. She's gone for a wander off again, back into the education area.
Yes, I'm sure apart from Andy Green, I have one of the best jobs today, because look at this, we're in the education zone and there is so much going on. There are so many people here as well, and at the moment there's even people drinking beer, which is excellent work, I feel. So yes, lots of merriment, lots of enjoying themselves, and I tell you what, let's come over here and try and talk to these guys, because they are clearly in the middle of something, aka watching themselves. Hello, what's your name?
I'm Jason Baker, or Cadet Baker.
Cadet Baker, what are you up to?
At the minute, we are just using these to entertain people by filling up those buckets or cups like this. And then once they're filled up, do you want to you'd flick it, or in that case, you'd use a little thing to create smoke bubbles, and it entertains people really.
Amazing, and that's to show us aerodynamics and the effect of it? I love it. Thank you very much for demonstrating. Good stuff. Well, sorry, what was your name?
Seth.
Are you a corporal, commander, captain?
Cadet.
Cadet.
He's not even got his uniform yet.
Not even got his uniform yet. What's your name?
Andy.
Are you having a nice day?
Yes.
You must like cars because of your top. Do you like cars?
Yes.
Yes. Okay, I'm going to leave you to it. Right, I'm going to walk around this way and hopefully you can follow me a little bit, because if I show you, we've got circuit boards, we've got programming happening. We spoke to Mike a bit. Hang on a minute. Mike's here. He's the educational team leader.
These girls are having a great time here.
I was going to say, how's it gone so far for the day?
Wow, absolutely fantastic. We've been bowled over with it. Everybody's now, particularly having seen that car run, they're coming and running their own car here, you know, and learning some of the bits about the coding of these cars, because our car has got 3 computers on it, and all those need coding as well.
It must be nice to have a real-term kind of, you go out, you see the car run, you see it, you hear it, and you see the flame coming out the back, and you can come here and you can understand what's happening.
Yeah. You know, a young girl came to me a bit early and said, well, we've just seen your car run. Can I now come and make this car go? Can I code this? Is it that easy? And wow, that's what really pays back.
It's awesome. I love it so much. Hopefully you're hearing us okay, because we're on the very large screen just up there, and the audio is quite loud, so hopefully it's okay. So you've got people over here, and they are designing their own engine and car to try and make a faster vehicle as they can, and they've designed a whole computer program around that to hopefully enable them to put it all together And then, as I said, design a fast. Hi guys, I'm just going to. Hello, I'm just going to interrupt you very quickly. How's it going? Are you against the time at the moment?
We are. We're not doing very well at the moment, I'll be honest.
Tom's got rid of the main bit of engine.
We're really bad at this. We're trying our hardest. We're trying to do teamwork, but it's not going well.
So this is one of the main concepts of this. You're meant to be doing teamwork. You can go and get different. Oh, you've just knocked over the timing stand.
I'm really sorry, everyone. Mum, I'm sorry.
So tell me what you're meant to be doing, because at the moment it looks like you're creating carnage in a room.
I think you're meant to just put all the parts that we have together to try and build our own rocket, and then I think it test runs after that, see how fast it reaches and how it performs against other people's, I think.
To the sign, I think.
Yeah, it's gone a bit AWOL, I think.
Yeah.
That's good though. Hey, that's going to go quick. Oh, whoa. Abby, can you? Abigail, please.
Time stand's the only thing stuck to the engine, so.
I was going to say, I fear aerodynamically that might be a challenged vehicle, but who knows? They're having a lot of fun anyway, and I just want to come over here because there's lots more people here. Hi, what are you guys up to?
Cars to make them go off the track.
Oh, okay. So these guys, they're making cars. I don't know if you can see, there's a massive box of different parts. They make the vehicle. Is yours ready to go?
Yeah, I've already tested it.
Can we go and test it again? Okay, what's your name?
Oscar.
Oscar? Come on then, Oscar. Let's see if they can go and test it again. So this is one of the big things over here, which is that they can build, they can build their vehicles just like this. And then over here, who are you with? Are you with?
This is Ben, yeah.
This is Ben. Okay, can you explain what he's doing at the minute for us?
So Ben has engineered a car out of Meccano and sellotape, and is putting it on the racetrack under pressure to see how it performs.
Okay, so hopefully, did you say Ben? I didn't mishear that. So he's going to press the green button. 2, 1, whoa! That was amazing. He left you hanging there. Anthony, he left you hanging. If you don't mind, we're going to go through the process and just, if you can talk us through what you're doing, would that be okay?
Yes, that's fine. What we're doing, just loading the car on now. We've got this beautiful car, almost looks like a Bloodhound design does this one. It's been running a number of tests. They go away, build the cars, come here, test it, run it backwards and forwards. You're just struggling there, are we? There we go.
Good job.
So we've got that launched. What we'll do now is pump up. I'll get some pressure, build up some air pressure within.
Hang on a minute. Let me just have a feel. How are your muscles doing?
Fine.
Are they okay? Is there enough muscle in there? Okay, go.
Right, that's 10, 15, 17, 20. That's what we want. Stop at that. Brilliant. Check the track. Can we just stand back from the track? So press the green button. 3, 2, 1. Launch. Right to the end of the track. Look at that. Brilliant car.
Amazing. So you can see there's a queue of kids. Thank you very much for teaching us through that. A queue of kids just waiting to start pumping, show their arm muscles, and also show their engineering prowess, which is amazing. And I tell you what, I'm going to take you for one little bit more of a journey. If we walk here, I'm going to go around here. Hello, sir.
Hello.
Hello. We're going to walk around here, and I wonder now, we tried to do this one before, which is aerodynamics airstreams. Hello, how are you doing?
Yeah, I'm good.
What's your name?
Salmon.
Salmon. And what's your name?
Chapman.
Salmon and Chapman. I'm assuming those are your last names. Otherwise I was going to say Salmon. That's an unusual name. Where did that come from? But we won't go there. So we have pom-poms, scissors, straws, and some sellotape, and some little cups. And what are you trying to achieve with this, Salmon?
We're trying to achieve the ball not coming out the top of the cup. So it shows people the gravity that happens.
Okay, and how successful is it?
It's really hard.
I have actually seen quite a few people down here trying to do this. Can we put some balls? Are you ready for balls? You've got balls in there. Okay, are you ready to have a little go? Oh look, they are staying in there. Oh, they are staying in. Okay, one fell out, but they managed to stay in there. This one's very good. Oh, to be quite honest, I'm the sort of person that would actually probably put all of the pom-poms in there and just blow really hard and see them all go. Yeah, come on, Salmon, you can do this. Go. Yeah. I love that. Thank you so much. And let's go around here. and have a little look what these guys are up to. Hello, what's your name?
Toby.
You had to think about that, Toby. Have you changed your name recently? No. Okay, that's good. Toby, and what's your name?
My name's Nat.
Nat. And what are you guys up to here? Do you know what the scientific process is behind the toys?
To have fun.
Yeah, that's what it is about here, having fun. And you are designing, which is, you know, one of the key concepts.
Random stuff.
Is this one of your designs?
Yes, it's very random.
I mean, it looks like one of the wheels on the Bloodhound. That could work.
Okay.
I mean, it doesn't have to. This is just a mega structure.
I just like building it.
That's fine. Are you going to go into something to do with engineering, mechanics, building?
Probably not.
What do you want to do?
What I want to do? I don't know. Something that pays well.
Something. You're a smart cookie. Right, I'm just going to come around here because hopefully... Whose is this? Is this yours? What's your name?
Zach.
Zach, now, can you tell me, if I move this slightly out the way, just so our camera can have a little look. Zach, this looks... Oh no, I've broken it. I failed the Blue Peter audition, unfortunately, but I'm not going to touch it now. I've really broken it, haven't I? Zach, just tell me what it is about this that I mean, why did you come up with this concept?
It's because I like building.
And do you like building things with wheels on?
Yeah.
I mean, this one, you've gone for 6 wheels on this. That's going to make it really flow, isn't it?
Yeah.
And any reason in particular for this nose? Because it looks like a very aggressive aerodynamic nose. It's going to cut through the air, isn't it, and send it all at the back. Yeah?
Yeah.
Right. Thank you so much. Guys, thank you very much. There's loads of stuff down here to keep everybody busy, so if you're coming over the next few days, you'll know that you can come and have a whale of a time. Guys, thank you very much. Say bye. Bye.
I'm not sure who's enjoying it more there, whether it's Jenny Gow or the youngsters that we're looking to try and inspire with this fantastic historic project. Just with us for one final question, Stuart Edmondson, who is the head of engineering operations for Bloodhound SSC, remains with us. We've spoken through lots of different things and what you and your team have been doing and the process that you'll go through at the end of the runs when we get out to the Kalahari Desert. But once we've finished here in Newquay, you are going to have several obstacles to overcome before we next run that car at very fast speed somewhere in the world. Just what do you think is going to be the largest obstacle that, as an engineering team, you will need to overcome between the end of this weekend and when we next run those cars at high speed?
Wow. We've got a long list of challenges. We've had a long list of challenges all through the program, and they'll be continued to be thrown at us. So, but the one thing I would say is we've now got data from a moving car, and we've also got the confidence that that car is moving. So I think the next challenge will be looking at the integration of the rocket, obviously, and how we do that, and also looking at taking the speed up and then gaining confirmation of the aerodynamic data from the car. But there's a whole host of them. I mean, this project is pushing the boundaries of everything. It's just every day is a challenge. You know, today was a challenge. We were ready for it, but it was a challenge, and we achieved it. So I'm not worried about the future. All I know, one thing, is it will be challenging.
You look more excited by the smile on your face. Thank you, Stuart Edmondson, for joining us in the studio. Well, you've been based in the hardened aircraft shelter down at the bottom of the runway, so it's about time you gave us a guided tour of your facility.
Certainly. I'm Stuart Edmondson, Head of Engineering Operations on the Bloodhound programme. We're going to spend a couple of minutes just talking about where we are at the moment and what we're up to. As you can see, we're in front of our hardened aircraft shelter. These were built during the Cold War to protect Royal Air Force's aircraft, but now it's ideally suited for what we're doing at Newquay Airport. This is where we do all of our engineering, all of our pre-use checks, post-run checks, and I'm just going to give you a brief outline inside. Okay, as you can see, central feature is Bloodhound, the car itself, with suitable lighting all around. And you'll notice around the car we've got various bays that provide the necessary support from in the far corner, the mechanical side, and then on the right-hand side the systems team are based. If we come on in closer, We then also position some of the critical equipment out to the side, so you can see on the left-hand side here the canopy, and that's all ready to go. So when we've done our pre-run checks, obviously these items are the last things that get fitted to the car before we roll the car out of the HAZ. So here the final preparations of the cockpit, some slight adjustments. We're installing cameras so we can capture the action, and that's being done now, ready for our runs later today.
It's a competition to see how many engineers you can get in the cockpit at once.
Yes. As you can see here, one of our bays is a fabrication shop, and we've tried to replicate all of the facilities we had back in Avonmouth near Bristol. So we've got the ability to make adjustments, minor repairs and so on. So on this side of the hardened aircraft shelter, we've got all our systems team. They're based here with the ability to plug into the car, update data, make software changes, and also all of the cable looms can be made and manufactured here on the spot if we need to make any adjustments. And finally, we've got our ground support equipment, which is crucial, obviously, for preparation of the car, including the ability to refuel it, and also our air start unit, which is vital for starting the EJ200. We also have our cooling rig that is here to support us in cooling down the car post-runs. Okay, that gives you a brief summary of what the activities go on inside the hardened aircraft shelter, which is vital engineering checks prior and post all of our runs. But the second important aspect of our location is the fact we're only a few hundred meters away from the airfield where we conduct our dynamic testing. And in fact, we're due to do some of that this afternoon.
So we saw and we heard the car run earlier on over the course of the day. And one of the questions I'm sure many people have is, what does it feel like to go at 1,000 miles an hour? Well, the answer is, nobody really knows. But ever the innovation within Bloodhound SSC. Driver Andy Green, Wing Commander in the RAF, has clocked up many hours flying Phantoms and Tornado jets, so there's no surprise that he's come up with a very novel way to simulate 1,000 miles an hour runs using his acrobatic plane. Sounds fairly alarming, but here is one person that has experienced that. It's Charlie Daggeter, who is one of the correspondents from CBS, who has had, I'm not sure whether it would be a pleasure of going up with Andy Green in a plane to simulate that 1,000 miles an hour run. Just how was it? Because it seems a very unusual, novel way of trying to replicate what it would be like inside the car.
It was incredibly exciting, and it was a pleasure. I mean, I was really nervous before he took off, and Andy, of course, told me what to expect, but you don't really know what to expect until you're in it. And when we first took off and we started pulling a bit of G, he said, okay, this is when you turn right, this is when you turn left, and you could start to feel the pressure on you. But then it was very specific. What he was showing me is what he does in order to prepare for this. So it is a very specific sort of 2-minute routine where at one point, the very worst of it was when we went inverted. So we're upside down, so it's sort of, I guess, negative G, and then bank, and then start turning right, so it's positive 2 or 3, so a net 4G, something like that. And that is to replicate what's happening in the car. Now, all I was thinking is, don't throw up and don't pass out. I didn't do either one of those things, but it put the strain on your body. And then when I got out of the aircraft, I felt it all afternoon and the next day, the tightness in your legs. I mean, the physical toll, the physiological effects on the body, extreme. Not for him, I mean, he's a specimen. For me, yeah, I was feeling it.
Well, I suppose those physical effects that you're talking about that they're maintained in your body, that's because, of course, the blood flow is going away from the muscle groups for a period of time, and therefore there's a small amount of trauma to the muscle for a period of time.
Not a small amount of trauma.
It was like a good gym workout, was it?
It was exactly like a good gym workout, because he told me, and this is very important, I was glad I asked this question. I said, because I mean, I've been in light aircraft before, but not thrown around in the sky like that. And when he said, I said, you know, do I hold my breath? do I tighten up? And he said, no, it's about the worst thing you can do, because your brain is already starved of oxygen. So you don't want to hold your breath. You do take a deep breath, and then you try to put some stress and clench your leg muscles as hard as you can. And even with all of that, I started feeling a little bit loopy right at the top as I was coming back in. And the extraordinary thing was, Andy's behind me, and he's not only maneuvering the aircraft, but he's giving me a play-by-play through all of it. And all I'm thinking is, I hope my eyes stay open long enough for the camera shot.
So it sounds absolutely fantastic. I think it's worth probably pointing out, whilst all of this was going on and your body was having to cope with those forces, there was no G suit, was there?
No. He made that clear. He said, it was going to be a bumpy start. It was a very bumpy runway, and you're getting thrown around. And then we get up in this wonderfully responsive aircraft. It was just incredible. And then I felt relaxed. And then once we started doing even just the simple maneuvers, you feel it. And it's hard to explain what G is. I mean, I guess when you're on the biggest roller coaster you've ever been on, and you can't even lift your arm. I mean, you can't do anything. And he even told me, too, as we said, we go upside down, he said, if you see anything on the canopy, grab it, because we don't know what it belongs to. So it's real, we're getting thrown around. And just the idea that he's not even breaking a sweat back there. I can hear him giving me the play-by-play.
Cool.
And that's what he's like. He's unshakable.
You mentioned roller coaster there, and that's the perfect sort of way to relate that back to the children that we're trying to inspire with this project. Is that you go on a roller coaster, and the bit where you can't lift your body out of the seat on the roller coaster, or the bit where your tummy goes down, that's 1.5, 2 G at an absolute peak.
Exactly. And one thing he made clear to me, and this is before, because I had interviewed him before, and I said, what's the worst part of it in terms of the physical toll? He said the deceleration is far worse than the acceleration. I think it's the way the body's designed anyway. You can push forward and you can withstand that. But he said it's equivalent from going 60 miles an hour to 0 in 1 second. So now you're pushed in that direction. So it's the deceleration when he's in that vehicle, which he tried to point out, and I have to say that is where the toll was taken on my body, because as we were going upside down, it wasn't the shoulder straps that were keeping you in, it was the ones that were across your thighs that were just holding you. And yes, that roller coaster sensation, you feel that, but well, for me anyway, it felt like times 10.
Andy's going to have to sort of cope with that for 55 seconds of acceleration under that positive G, pushing him back into the seat. And then, as you say, as soon as we ease off the throttles, we're decelerating so quickly, we end up with 3 negative G, pulling him forward for another 55 seconds almost.
Oh, and he's driving a car.
And having to do everything that he's doing.
And having to do this incredible mental checklist. When at a time when, all the oxygen is out of your brain, your equilibrium is thrown off, your inner ear, this is what was explained to me. I can't imagine it.
As a correspondent for CBS, you'll have experienced many things, more than I could ever care to imagine over the years. Some beautiful things, and also some probably quite awful things over the years being a correspondent. In terms of your memories of this is going to be one that surely must be right the way up there with the positive, the great things that you've experienced.
I've already dined out on it. Yeah, I've been to Mosul, I've been to Afghanistan, I've been to parts of Syria. That's some tough reporting, and it's not the kind of stories you want to share over a dinner party. But what is more exciting than this? And it's something that everybody can get excited about, because as it was explained to me by one of the engineers, like everybody has been in or has a car. I mean, this is a car on steroids, but is relatable. And when you have something that's exciting and there isn't anything negative about this, it's all positive. It's great to be able to share that.
You've been based in the UK for the best part of almost a quarter of a century now, if not a little bit more.
That old.
But you grew up and lived in Boston for a good period of time. You still must have family and friends and connections over there. So sure. The Bloodhound effect, it's crossed the Atlantic, surely.
It has, and we've tried to have some fun with the rivalry, because as you know, there's an American team, there's an Australian team, but as it was explained to me today, it's like they're kind of, if there were rear view mirrors, it's in the rearview mirror. I mean, the Americans have got a lot of catching up to do. But of course, we share that because it's a sort of global thing, Bloodhound. Everybody, it's a phenomenon. Everybody loves speed, right? Everybody loves trying to push the limits of technology, of human limitations, of mainframes. The idea of putting a jet engine on top of a rocket, I mean, it's cool. So of course, this is the reason we're covering it today, because it's something that people are fascinated about.
And I think you made a very valid point. We've alluded to this a few times throughout the course of the day. You know, there are competitors out there. We've got Roscoe McGlashan, who's looking to try and build Aussie Invader. He's had his difficulties, and hopefully he's overcome that last difficulty, and his project will now move forward. We've got North American Eagle with their attempt at it, which I agree with you. They're behind where we are. I think they are a fair way behind, but it's a very small community, World Land Speed Record breaking, so there is rivalry, but it's quite a friendly rivalry as well. And do you sort of get the feel of that as well when you talk to your friends over in the States who might be maybe engaged with the American project and rather than the Bloodhound one? You know, do you
well, one of the things that the Bloodhound team have been trying to amplify is the fact of this transparency, this data sharing, and this is data that is freely available to schools in the United States with the help of the Oracle and others. So they're looking. The folks who are trying to beat the land speed record in the United States, I mean, they only have to check to see the progress of this vehicle, and they share in the excitement. I would say that they're a bit envious because it's so tremendously well supported. I mean, it takes more than a village to put something like that together. I don't think we have quite the resources that you've got here in the UK to put something like this together. So it's a mixture of envy and excitement because, as you said, it's a small community. It's a friendly rivalry, and they're looking at the technology being used and, you know, pinching it here and there, as I'm sure this team has looked over at some of the stuff that's happening in the United States and maybe stealing off that too.
And the final question then, I'm not sure I'm envious about the fact that you got to go up in the aircraft. I'm not sure my stomach would be quite strong enough, but were you pleased to get back down on the ground?
I was, and you know, as a journalist, you can appreciate this. You know, there are ways of getting into an experience, and you can say, well, I'm going to shelter myself. You know, this is going to be extreme. The physical, the human condition is that we want to batten down, but you want to do the opposite when you're experiencing something like that. You want to open yourself to those experiences, and I didn't want to come taxiing down back onto that runway thinking, I really wished I paid more attention, and it was. As soon as we stopped, I wanted to go back up again.
You do it again?
Yeah, absolutely. It was great fun.
You must be absolutely mad. It scares the life out of me. And I think what we need to do then is probably scare the life out of some other people as well, because we've got a video that does show exactly what it's like to go in this 1,000-mile simulation with Andy Green of Bloodhound SSC. So let's take a look.
Being in Bloodhound, being at the end of a 12-mile track, and simulating the G profile that will take me to the other end of a 12-mile track in 2 minutes. So we're sitting there, all of the team is deployed across the track, it's all being checked, it's nice and clear. Just going to reverse the turn now, turn away from High Wycombe. And Bloodhound will now have its piston engine, the MCT V12 will be bubbling away idle, nicely warmed up. All the pressure will be checked, the tanks are pressurised, the jet engine will have started and be running on idle. The track will have been cleared, the rescue crews and the monitoring crews will be at the right place. And with all of that in place, I will be given clearance to roll by the run controller. So I'll ease off the brakes, put the power on and wind the jet engine up to full power, full drive power straight away. Half accelerating at about half a G. As we get up to 100 miles an hour, engage the reheat and immediately get minus 1 G acceleration, 20 miles an hour per second. So 150, 170, 190, 210. Now looking for the stage 1 rocket. Squeeze the trigger on the steering wheel. About 4 seconds later, get the stage 1 rocket like that. A little bit more negative G. Now coming up to 250, 270, 290. Pushing 300 miles an hour. Looking for the Q for the stage 2 rocket. As we fire that up, it kicks up to 1200 rockets. That's 40 miles an hour per second acceleration. We're now doing over 450 miles an hour. 500, 550, 600. Airflow starts to go supersonic over the canopy. G's back in your front, still doing over 1 G. We're now doing 750 supersonic, 800 miles an hour. Still accelerating at over 1 G. 900 will take 4 seconds now to reach the measured mile. When we get there, it will take 3.6 seconds at over 1,000 miles an hour. Remember, tensionate your stomach, so we simulate range of throttles now. And going to 3G deceleration, 60 miles an hour per second, coming down through 900 miles an hour, 850, 800, 750 miles an hour. We're coming back to to a subsonic speed now, 700 miles an hour. The drag is dropping off, but we're still doing over a mile every 6 seconds, so 650 miles an hour. Bringing the ship back out, extra 900 drag, back up to 3G, and as we lose the speed to 500, 450, now coming down to 400 miles an hour, gradually backing the G off as the aerodynamic drag comes down. We're now trickling down to 1G, approaching 300 miles an hour. We're inside the last mile or two of the run, looking for 200 miles an hour, and just gently easing the wheel brakes on. Actually slow the car down to a stop 12 miles later, and after 2 pits. How are you feeling now? That's outrageous! Great, isn't it? I like the fact that it had some structure to it. It didn't just feel like someone was trying to terrify me. I felt like I was in a process. Maybe I'm such a binary creature, I needed that. Did I enjoy it? Not for a minute, but it was a hell of an experience. Well, land speed record is a bit like that. It's a lot of work and some physical discomfort, but there is no other experience like it.
Well, we've been talking throughout the course of the day about the goal of Bloodhound SSC and its main goal to inspire that next generation of scientists, technologists, people who are involved in engineering and mathematics. So one thing we need to do is take a quick look at just one of the ways in which the project is looking to inspire that next generation.
No reason why it shouldn't go back.
Are we ready?
3, 2, 1.
You're officially in the world record holders, and you're officially amazing. Well done.
That's just one of the ways in which Bloodhound SSC delivers projects on the ground floor to engage that next generation of students and children about science, technology, engineering and mathematics. But it also has a small army of volunteer ambassadors that help deliver that, and an education team as well that tour the country providing hands-on workshops to children and individuals. And I've got two people from the education team alongside me. I've got Kirsty Oldpress and Rob Bennett, members of the education team.
Hello.
Hello. It looks as though in your little area, where Jenny Gow seems to have spent an inordinate amount of time enjoying herself today, that you've also had plenty and plenty of our target audience, those small young children and people that are heading through schooling and looking at future careers. They've all been busy enjoying themselves, Kirsty, there.
Absolutely. I mean, I think you can see the excitement, and the good thing about these activities is they are, as you say, for all age ranges and all abilities, and everyone can get involved, and they're really hands-on, and I think you'll agree it's been really exciting over there today.
we've seen, statistics and figures about the quantity of children that we've reached in the UK over the course of the last few years, and we're talking not hundreds or thousands, we're talking millions.
Yes, I mean, to give you an example, last year we reached over 130,000 children with all of the workshops and activities we've been doing. So over the course of the number of years we've been running, yes, we're running into millions now, which is fantastic. It's a phenomenal effect.
And the way that they engage with the project, it's in schools, it's with social media as well. When you go into schools and deliver, just one of the workshops that we saw there, the rocket car workshop, what's the effect in the school when you do that?
Well, I think the video showed it quite nicely. I mean, it really gets everyone engaged. There's excitement, there's energy, and the great thing is it's not just about the one day that we go in to visit the school. We actually work with the teachers as well to get them involved, and we gather data from all of the activities that they do and give those to the teachers so that they can carry on and analyse that data and look at it going forward. So we're trying to, inspire teachers as well as the students that we're working with.
So if you're gathering data, we saw the rocket cars there. Do they have something inside them that allows the data to be gathered then, similar to the real car?
Yeah, absolutely. So they have data gatherers in there, accelerometers, and we gather that data and give it to the teachers. It varies according to how long we have with the group. Sometimes it's just a quick taste. Other times we get to spend a whole day with a group of students. And you can see inside today we've been working with coding as well, so it's not just utilising the coding technology, it's actually getting them programming as well, which is something that schools are really, some of the teachers need help with and the students love and really get on board with and really engage with. And
these workshops, if we're talking about accelerometers inside cars and things, that's for children that are sort of in academies in secondary school, as was. What about those that are sort of in primary?
Well, actually we have a lot of interest in primary schools, and some of the primary school children really get it really well, and they have some, it helps if they have a really enthusiastic teacher, but we go in and work with them and get them involved. We're doing a lot with microbit at the moment and with Vex Robotics, and we're going and doing all sorts of activities. Rob,
you're also heavily involved with the project and have been on the education side, amongst other things, for a very good number of years. Tell us about your experiences and maybe just the one thing that before you came into this project and started delivering what you deliver into schools that you just never would perceived would have happened with young children.
With the technology that's available now, even in the length of time we've been having this conversation, technology has moved on. So how do we keep pace with that? How do we encourage and inspire young people? That's what we've seen in schools, is young people taking those technologies and asking questions. So why? Why is a massive question, and we do it when we're 10, and then when we get older we stop asking why. But it's so important to interrogate and investigate and be curious about things, and we embed that into our workshops, and young people start to see the world in a slightly different way.
I think that the difficulty with some aspects of education at the moment is that the national curriculum is clearly a very structured thing, and therefore all teachers are quite confined as to how they can deliver certain subjects. And do you find that with what you do it allows you to maybe circumnavigate some of that?
Well, I don't even know whether it's circumnavigate, to be quite honest with you. We just see things in a different way. We're project based. So there are schools that actually take what we do and see that we deliver on the curriculum in spades across the curricula, because of course real life isn't subjects. We have to engage in all of those things all of the time. We're all doing it in all our jobs and when we're growing up and when we're working and whatever it is that we're doing. So we bring that to the schools, and it helps deliver real understanding and embedded learning of that curriculum in a very practical way.
Kirsty, maybe could you just give an overview of some of the types of workshops that are available to schools, just briefly, and what they're geared around when it comes back to the car in terms of its relation?
Sure, absolutely. The one thing, as Rob said, is they're all really hands-on activities, so the idea is we bring the curriculum to life. So something they've been learning at school, and we can tie it in with the curriculum across the year, so they then can do some practical activity around it. Rocket cars we've seen is a very popular one, also the coding with the robots. We have, if you've been into the education area, you can see there are 2 scale models of the car, which we can actually take into a school, so we can bring the sheer size and scale of Bloodhound into a school. Wow. And they can actually see it, and they can do activities all around it. And we have our what we call Tour and Explore, and our sponsors are really important with that, because all the key components that are in the car, we talk about all of those. And the other thing we do is hands-on work with the teachers as well, to give them follow-on activities they can do with the students when we've left.
I think we've got another nice little video that we can play, because it's not just model rocket cars that Bloodhound have got. So the Bloodhound education team and Bloodhound as a project have the world's largest airfix kit, and we'll just have a quick look at that.
Okay.
It is relevant because, you know, many of the things that we saw there in terms of the components of the real car, you know, that was the real car there with a real Andy Green sitting at the front, are fundamental in terms of some of the other workshops that you delivered. I've seen not just rocket cars, Rob, I've seen you using Connect, which most children nowadays will have grown up with, but you again deliver a workshop in a very different way that utilises that.
One of the things that is critical in terms of lifelong learning and engagement with the world of work is not just about those core skills like physics or maths or English even, but about embedding competence, employability skills, working in teams, time management, limited resources, and then we can actually get them to, in effect, replicate what Bloodhound is trying to do in a very real way. It's very dynamic, very real, and sometimes you get disasters and failure. But of course, failure is part of learning, and it's a critical part of the engineering process. And as well, of course, if you're involved in scientific exploration, you have to learn to fail and then learn from those experiences. And encouraging young people to fail is, I think, a critical part of learning, and we embed that into all that we do.
So those, when you build Connects, that's the sort of air-powered cars, isn't it? The children have to work out how to build it, work as a team, and try and build it so that it's strong as well, I suppose.
Absolutely. So they're embedding Newton's laws of physics, laws of motion, and also engineering structure, and they will learn, and they know instinctively that the car veered off to the left when they launched it. What do they need to do to fix it? They know. They absolutely know. I don't need to tell them. I just need to get them to investigate, have a go, change it, make it better, and improve it. And then you see demonstrated fantastic embedded learning.
We keep saying that, you know, we see this skills gap looming, but also, you know, you're one of many female members in the project, Kirsty. You know, we know that women generally are underrepresented in some areas of industry. You know, do you see a positive response from young female children when you go into schools? Do they engage in the same way as perhaps males do?
Absolutely. I mean, they do engage really well, and often the girls have to do pretty well in some of the activities, the Connects that Rob mentioned and rocket cars. Quite often they outdo the boys in some of these activities, yeah. But I think what's really lovely to see is at the beginning of the day, some of the girls sort of hang back a bit and aren't really sure about it, and it's not something they necessarily considered, but by the end of the day, like, wow, I hadn't really thought about this as a career or the kind of things I could do. And to try and reinforce that, we get parents involved as well. So we might do a day of workshops, but then we'll say to parents, well, why don't you come along afterwards and see what we did and give them a taster, because it's important to get their buy-in as well, I think, which does encourage more girls, because sometimes parents think, well, is that really a good career for them to go into? Should they be doing that? So we reinforce that message as well. And we do get lots of inquiries from schools, particularly girls' schools, and actually what's interesting is seeing the girls working with the boys as well in mixed groups, particularly with rocket cars where they are team working, and you see really good results when you mix them together as well. So.
And all of these workshops that you're talking about they're delivered in, it might be the same workshop, but it's delivered in a subtly different way, subject to the age group that you're doing it for, Rob?
Yeah.
Very much so. We do take note of what the curriculum is trying to deliver, and we can embed layers of learning. So, for example, Connects workshop, you could do that in nursery. You could do it at undergraduate level at university, and our education partners, University of West of England, actually use Connects to build rocket cars pumped by air pumps with their university undergraduates studying engineering and physics, because it works.
Well, I gathered, you know, I've heard so many fantastic stories, and I'm trying to weed out how many of them are sort of wives' tales and how many of them are true when it comes to this project, because it's been going on for such an enormous amount of time and has developed so much. But one of the stories I heard earlier on today for the first time was that, you know, we've heard about the titanium steering wheel being moulded, 3D printed out of titanium to Andy's hands, but that started, if we go back from all of the different iterations and developments of that started with a piece of cardboard. Is that true?
Absolutely true. And in actual fact, we when we have done 3D printing workshops in schools, we had that prototype, the cardboard prototype,
just to see if it would work.
Exactly, and I've had the privilege of working based at the Bloodhound Technical Centre, and I've seen cardboard boxes with masking tape making the fuel tanks before they eventually made them out of carbon fibre. It's part of the engineering process, and sharing that totally open source is really helping people to understand that learning process.
Final question for you, Kirsty, before we then just grab one final sort of response from Rob. Engineering, you know, it's still that global term that we need to try and get people to understand that it's not just one thing, engineering, it's an enormous sector with so many opportunities.
It is, and that's where our ambassadors and partners come in, and the sponsors, because they can highlight all those different types of jobs within it. So when we're going out talking to schools and talking to children about opportunities, we can give them examples of all the kinds of things that they can do, and the ambassador team come out and support us at events, and it's great because they can bring their anecdotal stories about what they're doing in industry as well and how it fits in, and so it really does open things up for children, gives them an idea of the kind of opportunities that are out there and what they could be doing.
Right. And Rob, just final one. I know it's slightly tongue-in-cheek, but you must remind me of your job title when it comes to Bloodhound SSC.
Chief Inspirer.
Chief Inspirer. Okay, so Rob Bennett and Kirsty Oldpress, thanks for joining us. Rob Bennett, our Chief Inspirer at Bloodhound in the Education Department. So let's have a look at a day in the life of the Chief Inspirer.
3, 2, 1.
Whoa, awesome. Oh, cool.
How was that? My name's Rob Bennett and I'm Chief Inspirer at Bloodhound. But I can't do that on my own. There is a network and group of people around, as there are teachers like Claire Nobes at the Castle School where we're going today. They put in an awful lot of effort. The teachers organise after-school clubs and lunchtime clubs. They take those resources out to their primary feeder schools and engaging to that wider community.
D&T we find is the practical application of maths and science, and it's where children make that connection between what they're doing in those lessons. So just by measuring and actually looking at stresses and strains on materials, they don't sometimes realise it, that they're actually using skills that they've developed in maths and science.
Right, shall I put any load on it at all?
No.
Shall I blow on it? Ready? Ready? Should we all blow? Let's all blow. Let's see how good it is in a storm. 1, 2, 3. There we go. That's the end of that one.
We get a good uptake at GCSE level, but then still more boys than girls. And one of our aims by doing a lot of these STEM activities is to actually try and encourage more girls into engineering and the possible careers that they could take down the route. So it's really good to see them being very passionate about the subject in Year 7. It's trying to gain retention and keep them really inspired, you know, for them to follow that as a career path.
Concentration, is that a word? Ready? 3, 2, 1. Hooray! The best part of my job is seeing young people, and of course the grown-ups that have responsibility for them, their eyes light up because it's opened their thinking. They're engaged, they're inspired to do things in a different way, to start believe in new things and new ideas, and that really encourages me. And when I get feedback from teachers or from students or from parents, how their young people have taken those things on board, those new ideas, and gone off and explored things, it's really, really exciting to think that you actually make a difference to the way people see the world. Really, really encouraging.
I want to design the next really, really fast car that goes faster than 1,000 miles per hour. The speed of light. I want to go faster than the speed of light.
Well, we're coming to the close of our day here at Cornwall Airport in Newquay, and we've still got a few things to look back at throughout the course of the day, but Jenny, you're back here in the studio, back in the warmth again. It has been a memorable day, I'm sure, for everybody that's been here and for everybody that's watched online as well.
Yeah, I've had such a fantastic time, and I hope everybody who's been here and who's watched the stream has had a great time too. You might not have broken as many things as I have, as I've made my way around the education zone.
No, come on, do tell.
Well, no, it's just small children's cars. I seem to have a habit of just putting a hand out to go, oh look, and then it just a wheel falls off or something. So yes, I don't think they're letting me back in the education zone, which is why I came back over here, because it seems safer, easier place for me to not touch and break stuff. But it's so cool over there, because trying to get across to children and young people that engineering is a cool thing sometimes is a really hard task. And, you know, I might be on the road with Formula One and that sort of inspires people a little bit, but actually there is nothing better to inspire people than to actually get your hands on things that you can touch, that you can feel, that you can have an effect on. And if that's an aerodynamic effect, or if it's a design effect, as you've been saying all day, there are so many different parts to engineering.
Yeah, absolutely.
And to go over there and be able to take part in as many of those as possible is just such a cool environment.
I think to be able to bring them to life, you know, if you're in a classroom environment, you know, the learning has to be there, and it has to be structured learning, absolutely. And with Bloodhound SSC, it is still structured, but I think the way that it's done is very clever from what I've seen throughout the course of the day, because the children are learning, and they don't know they're learning.
Yes, they're very up for it if they don't realise it. It's just a brilliant platform for it. And I just wondered, for you, you've been involved in this project for a long time, I think it's fair to say. How have you felt seeing it all come to fruition, being able to sit here and, you know, commentate on Bloodhound going down and doing 208 miles an hour?
It has been an absolute pleasure to be involved with the project for, 4 years now, just over. And this day was always going to come, and I was so pleased when it was announced, and there was a little lump in the throat, you know, because it looks fantastic. It's a wonderful site, and yes, there's still, don't get me wrong, there's still a long way to go. You know, there's still a lot that we need to do to move the project forward, and with the likes of Andy Green, with project director Richard Noble, with Ron Ayres, and all of the people that we've had in the studio that have given up their precious time to be with us today to put the message out there. I have absolutely every confidence in the world with them, and with our ambassadors, and with all of our corporate supporters that are supporting the project, that we will get there, that we will break the land speed record, and that we will achieve 1,000 miles an hour.
I mean, when you look at the future and the involvement of all the people here today, people are online, the kids, the next generation coming forward, it's really exciting to think that all of these people could be seeing a major movement within, you know, British achievement. It's just, I find that quite awe-inspiring.
Well, I think it's, you know, a global achievement. You know, if as a species we can push those boundaries continually, and you look at some of the early innovators, and you know, some of them their ideas were considered ludicrous at the time, or it couldn't be done. And as we heard from Ron Ayres earlier on, people suggesting that breaking the sound barrier on land was impossible. Well, the best way to prove that it's possible is to do it, and the man just over your left shoulder is the man that did that, Andy Green, Wing Commander Andy Green. So, and had it not have been for people that wanted to try something different and do something different, and going back billions of years, you know, as a civilization we have evolved, and we keep evolving, and technology keeps evolving. What better showcase that we've got than that blue and orange thing that is 20 metres away from our studio?
It's still amazing the amount of people who are here, who are coming down to get their picture taken with Bloodhound, and to see, you know, what is over in the education zone and how that matches up with seeing it in person and meeting Andy. And I think Andy's done the rounds of everybody today and spoken to the world and spoken to almost everybody here as well. Even now, there's a gentleman stood outside the front of our studio waiting to have an autograph from Andy, because it's a piece of history and it means a lot to everybody.
And I think, you know, if it means...
He's off. Andy, goodbye. No, it's okay, you can go now, but thank you very much. Yes, go sign autographs.
He's not off duty yet, he's not off duty yet.
Andy has now left the building. He's just left it and will be out there for a while.
He will be out there for a very long period of time. I don't think his day is going to finish for, what are we now, we're just coming up towards 4 o'clock. I don't think his day is going to finish for probably another 5, maybe even 6 hours yet, from what I gather. So a long, long day for him, and he's got to do it all again, because today was the first public test. We will let the car rest tomorrow. The engineers will do what they need to do, and we will repeat this process with this more. It's vital, as we've heard earlier on from Stuart Edmondson, you know, it's vital for the car, but it's vital for his team as well to practice what they need to do, not just on terms of the engineering side, but also what's going to go on in the desert when the car gets to one end of the run, and they have to think about all of those processes and all of those roles that will take place. So this testing time is critical for everybody.
Yes, so Saturday, More people coming. We're expecting lots of people down here, maybe over 3,000,
Yep.
which I expect is going to cause a few traffic jams. Yes. And then when we get to Monday, that's when we open the gates up to all the local children.
4,000 plus children from of all ages coming from around Cornwall and the surrounding area to be here as well. So, that will be, a day which will certainly keep the education team busy. They will be absolutely run off their stocks, and in the absence of you, because you're not here, hopefully some of the cars that the children have built might even survive as well. You never know.
That is so true. I expect there will be a lot more successful scientific experiments and engineering feats in the other room.
We want people to keep liking and supporting us on social media as well. The hashtag Bloodhound has been working. I think I've had 4,000 new likes on the SSC website today. And you know what? We even managed to break the website earlier on. Do you think we might be able to bring it down again later on if we push hashtag Bloodhound is go?
Well, that was always the aim. If you can break the website that you're on, that's a good thing. So, just thank you really for all the support that we've had today, for all the love that everybody's shown us, and all the hashtagging that's happened, because loads of people with selfies, tweets, you name it. It's been brilliant.
You've had fun?
I've had a blast. Thank you so much for having me.
Delighted to have you. As we heard earlier on, then the car will be running next year, and we'll be pushing the speeds higher than we've ever pushed them before. And so stand by for some exciting news with regards to that, because we know it's going to be pushing speeds. We don't know where, we don't know what speeds, but we know it's going to be doing very high speed runs next year. Once again, thanks for joining us here at Newquay. Let's just take a look back at some of the highlights of the day.
It's been a big day. It's been a fantastic day. We've done a lot of work over many years, and over the last few weeks, the trials that we've done have just shown that we can run this car at high speed.
Just cannot wait. Having demonstrated Bloodhound is go, we've now got a clear plan to go faster next year, and more importantly, got a car that's already proving it is not just as fast as we're expecting, it's working better, it's more reliable, it's faster, and the team is just brilliant.